Imagine stepping outside on a clear, moonless night, far away from the blinding glare of city lights. You look up. A faint, shimmering river of light spills across the black velvet of the sky, a celestial trail of cosmic dust and glittering, distant stars. It's a sight that's captivated humanity for millennia. We called it the Milky Way. It's our home. Our entire world, our history, every person who has ever lived, has existed right here, inside this single, sprawling city of stars. Welcome to the Science for Deep Sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. And for as long as we've understood our place in the cosmos, we've also dreamed of leaving it. Of venturing beyond our galactic shores to explore the boundless ocean of intergalactic space. It's the ultimate journey, the final frontier. But here's the twist, a horrifying truth hidden in the very fabric of space and time. Imagine you're on that grand voyage, the greatest in human history. The engines ignite, pushing your ship past the familiar constellations, past the swirling arms of home, and into the silent, perfect black. You think you're an explorer. But as you cross what you believe is the final frontier, a chilling realization dawns. You're not an explorer. You're an exile. You can never go home. And the reason why is far more terrifying than you could ever have imagined. The dream and the deception. So, why would we even try to do something this crazy? The motivations are as varied as the stars themselves. Maybe it's born of desperation. In some distant future, our sun, like all stars, will start to die. It'll swell into a bloated red giant, scorching the inner planets and turning Earth into a lifeless, charred cinder. To survive, humanity would have no choice but to become a species of travelers, looking for a new home around a younger star. Or maybe it's not fear, but pure curiosity. The same insatiable drive that pushed our ancestors to cross oceans, to look at the moon and say, we're going there. It's just in our nature to explore, to see what's over the next hill. And cosmically speaking, the next hill is another galaxy. The dream would be to build a ship capable of making this leap, a testament to a civilization that has mastered its world and is now reaching for others. An ark, not just for people, but for all the knowledge, art, and spirit of our species. Imagine the ship itself. Not some cramped capsule, but a world in its own right. A starship kilometers long, a shining testament to our technology. Inside, generations would live and die, their only purpose to shepherd the light of human consciousness across the unfathomable darkness. The mission: cross the void and set up a new home in a neighboring galaxy, like Andromeda, our closest major galactic neighbor. From here, the task seems deceptively simple, even if the scale is mind-boggling. The Milky Way, as we see it, is a flattened disk of stars, gas, and dust. A brilliant, swirling pinwheel about 100,000 light-years from edge to edge. Our solar system is in a quiet, suburban neighborhood called the Orion Arm, about 27,000 light-years from the chaotic, supermassive black hole at the galactic center. So, to leave, it seems like you just have to pick a direction, up, or down, out of the galactic plane, or straight out toward the edge and just go. The plan seems clear. You point your ship away from the glittering disk, fire up the engines, and watch as the familiar river of light shrinks behind you. You'd see something no human has ever seen: the entire Milky Way galaxy, a majestic spiral of impossible beauty, turning slowly in the void. You cross the 1,000 light-year thickness of the stellar disk, passing the last lonely, far-flung stars. The light of home fades from a brilliant band to a bright smudge, and then, to just another dot of light in a sky filled with them. You've done it. You've left the galaxy. But this is the first great deception. You've crossed a finish line, yes, but it wasn't the asterisk real one. You've left the bright, bustling city, but you haven't yet left the vast, invisible territory it controls. The hardest, and most terrifying, part of the journey has only just begun. You haven't escaped. You've merely entered the outer walls of the prison. The impossible obstacle, redefining the finish line. The brilliant, luminous part of the Milky Way, the part we see in all the pictures, is a lie. Or rather, it's only a tiny fraction of the truth. It's like looking at a city at night and thinking it ends where the streetlights do. You're ignoring the vast infrastructure and the unseen forces that hold the entire region together. The true Milky Way is far, far larger, and way more massive, than the light it puts out. To get the real scale of our galaxy, we have to talk about the one thing holding it together, gravity. And to talk about the galaxy's gravity, we have to talk about something we can't see, can't touch, and can only detect by the massive influence it has on everything we can see. We have to talk about dark matter. For decades, astronomers were stumped. When they measured the speeds of stars on the outer edges of the galaxy, they found something that broke all the known rules of physics. These stars were moving way too fast. Based on the visible matter, the stars, gas, and dust, these outer stars should have been flung off into space, like kids flying off a merry-go-round that's spinning too quickly. The gravity of the visible galaxy just wasn't strong enough to hold on to them. The only explanation was that there had to be more mass. Lot more. A vast, invisible sphere of matter enveloping our entire galaxy, pulling with so much gravity that it keeps everything in check. This is the dark matter halo. It's the true shape of our galaxy. Recent simulations and observations suggest this halo doesn't just surround the starry disk, it dwarfs it. While the part we see is about 100,000 light-years across, the dark matter halo is estimated to stretch out to a staggering diameter of nearly 2 million light-years. Let that sink in. The home we thought was a 100,000 light-year wide structure is actually a tiny, glittering jewel inside a monstrous, invisible sphere 20 times its size. Leaving the stellar disk isn't escaping the Milky Way. It's like walking out of your house and finding you're at the bottom of a canyon 2 miles deep. You're out of the house, but you haven't gone anywhere. This is the true finish line. To really leave the Milky Way, you don't just have to travel 1,000 light-years up, out of the disk. You have to fight your way out of a gravitational well that's nearly 1 million light-years in radius in every direction. This brings us to escape velocity. Here on Earth, to launch a rocket into space so it never falls back down, you need to hit about 11.2 kilometers per second. That's the speed needed to beat Earth's gravity. The Milky Way has its own escape velocity, and it's monstrous. From our position in the Orion Arm, an object needs to be traveling at an estimated speed of around 550 kilometers per second over 1.2 million miles per hour to even have a chance of breaking free. Let's put that in perspective. The fastest object humanity has ever launched is the Voyager 1 probe. After decades of travel and multiple gravity assists from giant planets, it's cruising at about 17 kilometers per second. That's incredibly fast for us, but it's less than 4% of the speed needed to even begin to escape the Milky Way from where we are. Voyager 1 isn't escaping the galaxy. It's destined to orbit the galactic center for billions of years, a tiny piece of human-made debris trapped forever in the galaxy's gravitational cage. Now, astronomers have seen a few rare, hypervelocity stars that are actually getting kicked out of the galaxy, like one called CYS J1249+36, often after a chaotic dance with the supermassive black hole at the center. But these stars are cosmic lottery winners, flung out by forces we can't control. For us, trying to leave on purpose, we'd have to build a machine that can hit that escape velocity and keep fighting gravity for millions of years. The sheer scale of this invisible obstacle is the first horrifying truth. The galaxy doesn't want to let you go. The tyranny of distance and the speed limit. So, the scale of our prison is now clear, a nearly 2 million light-year wide sphere of dark matter. But size is just one problem. The other is speed. And here, we run headfirst into the most famous and unforgiving law in all of physics. Let's pretend we solve the energy problem. We build an engine that can get our ship to the required 550 kilometers per second escape velocity. What does the journey look like now? A light year is the distance light travels in 1 year, about 9.5 trillion kilometers. The edge of the Milky Way's dark matter halo could be 1 million light-years away from us. Our fastest probe, Voyager 1, travels at 17 kilometers per second. At that speed, it takes Voyager about 18,000 years to cover a single light-year. To cross the 1 million light-year radius of the dark matter halo, Voyager 1 would need 18 billion years. That's longer than the current age of the universe. The universe itself is only about 13.8 billion years old. Before our ship could even escape the gravitational pull of our own galaxy, the universe as we know it would have aged into something unrecognizable. The sun would be a long dead, cold cinder. The journey itself would outlast the civilization that began it. Clearly, 17 kilometers per second won't cut it. We need to go faster. Much, much faster. We need to get close to the ultimate speed limit, the speed of light. In a vacuum, light travels at a constant 299,792 kilometers per second. Nothing with mass can reach this speed. Einstein's theory of special relativity makes this brutally clear. As you accelerate closer to the speed of light, your mass increases, and the energy required to go even faster grows exponentially. To reach light speed, you'd need an infinite amount of energy. It's a fundamental wall built into the fabric of reality. But what if we could get close? Let's say our ship is a marvel, capable of traveling at 99% of the speed of light. Now we're talking. The journey across the 1 million light-year halo is no longer billions of years. It's now only a little over 1 million years. A 1 million-year journey. Let that sink in. 1,000 millennia. Homo sapiens have only existed for about 300,000 years. The whole of recorded human history is a mere 5,000 years. Your trip to the edge of your own galaxy would be 200 times longer than the entire span of human civilization. This is the tyranny of distance. The numbers are so vast they become almost meaningless. But for the travelers on that ship, they would be horribly, crushingly real. They'd be ghosts in their own time, voyaging for more than 1 million years, all while still technically being inside their home galaxy. And this assumes a straight shot. In reality, it would be a relentless, uphill climb against the galaxy's gravity. The energy needed would be astronomical, requiring a power source like harnessing the entire output of a star or using matter-antimatter annihilation on a colossal scale, just to keep pushing against the pull of home. So we have two impossible problems: the impossible size of the dark matter halo, and the impossible time it would take to cross it. The dream of a quick hop to another galaxy is dead, but surely, humanity's ingenuity can find a cheat code, right? This is where hope comes in. And with it, a whole new kind of horror. The flawed solutions, false hope and horrifying flaws. If a straight line won't work, we have to look for a cheat code. Science fiction has given us plenty of ideas, and some even have a basis in real theoretical physics. But every single one comes with a terrible, horrifying catch. The first flawed solution, the generation ship and the weight calculation. The first, most realistic idea is the generation ship. If the journey takes longer than a lifetime, the ship has to become a self-sustaining world. A sealed biosphere, a tiny Earth, carrying thousands of people on a multi-millennial voyage. The first generation would be pioneers, sacrificing their lives so that their distant descendants, maybe 40,000 generations later, might see a new star. It sounds noble, right? But the psychological reality could be a nightmare. Imagine being born on that ship. The cold, metal walls are your world. The sky is a simulation. You're born into a purpose you didn't choose, a link in a million-year chain. Your entire life is dedicated to a mission conceived by people who have been dust for longer than your species has had language. Even short-term isolation on the International Space Station causes anxiety, depression, and conflict. Now imagine that for tens of thousands of years. What happens when a new religion forms? When a political faction decides the mission is pointless and wants to turn back a maneuver that's physically impossible? The ship could become a floating asylum, its inhabitants driven mad by their inescapable fate. But even if the society holds together, it faces a soul-crushing paradox: the weight calculation. It's simple. A generation ship, let's call it the Endeavour, launches in the year 3000 with the best tech of its time, moving at 1% of light speed. The trip will take 100,000 years. But back on Earth, technology doesn't stop. 1,000 years later, engineers build a new engine that can go at 10% of light speed. A new ship, the Odyssey, is launched. Its journey will only take 10,000 years. Simple math says the Odyssey asterisk will get there 89,000 years before the first ship. The descendants on asterisk the Endeavour, after 40,000 generations of sacrifice, would arrive only to find a thriving colony that was set up tens of thousands of years before they got there. Their entire existence, their ancestors' multi-millennial sacrifice, would be utterly pointless. Knowing this, why would anyone ever get on the first ship? It's a philosophical trap that could stop any attempt at interstellar travel before it even starts. The second flawed solution: time dilation and the ghost ship. Okay, so generation ships are a psychological nightmare. What about going faster? Let's push our ship to 99.999% of the speed of light. Now, we hit another of Einstein's strange predictions: time dilation. As you get close to light speed, time itself slows down for you relative to everyone else. For the crew, the million-year journey might only feel like a few decades, or even a few years. They could leave Earth, travel to the edge of the galaxy, and come back, having aged only 40 years. Sounds like the perfect solution. But it's a monkey's paw wish. You return from your 40-year trip. But while you were gone, 2 million years have passed on Earth. Everyone you knew is gone. Your family, your friends, your entire culture. They aren't just dead, they're less than dust. The continents may have shifted. The human species itself might have evolved into something new or gone extinct. You'd return to an Earth more alien than any world you could have visited. You'd be a ghost from a dead past. This isn't a round trip. It's a one-way ticket that leaves you stranded not in a different place, but in a different time. The third flawed solution: the warp drive and the unintended weapon. This brings us to the Holy Grail, the warp drive. Specifically, the Alcubierre drive, a theoretical idea from physicist Miguel Alcubierre. This drive wouldn't move a ship through space, it would move space around the ship.
It would create a bubble of normal spacetime around the vessel, then contract space in front of it and expand space behind it. The ship inside the bubble stays still, so it never locally breaks the speed of light. But the bubble itself could theoretically move faster than light. It's the ultimate cheat code, but it has a terrifying potential flaw. As the warp bubble travels, it would act like a cosmic bulldozer, scooping up interstellar particles, dust, hydrogen, cosmic rays. Because of the extreme warping of spacetime, these particles would get trapped at the front of the bubble and energized to incredible levels. The longer the journey, the more particles and energy you collect. So what happens when you arrive at your destination and turn the drive off? The bubble dissolves, and all that built up, hyper-energized matter is released in a single, catastrophic blast. The ship might be fine, but it would unleash a wave of gamma rays and high-energy particles that could instantly sterilize whatever you came to see. If you were arriving at a new, life-bearing planet, you might vaporize its atmosphere and boil its oceans in a fraction of a second. You wouldn't be an explorer, you'd be an unwitting god of destruction. The Alcubierre drive might not be a transport system. It could be a planet-sterilizing superweapon, and you wouldn't even know you'd fired it. The ultimate one-way trip. The final, unbeatable trap. Let's indulge in one final fantasy. Imagine we solve it all. We build a stable generation ship, figure out the weight calculation, and invent a warp drive that doesn't annihilate our destination. We achieve the impossible. We cross the 2 million light-year diameter of the dark matter halo and finally drift into the true, empty space between galaxies. We're free. The crew celebrates. They've done it. They've left the Milky Way. They turn their ship around to take one last look at home. It hangs in the blackness, a breathtaking spiral of light. And now, they decide, it's time to go back. And here, they discover the final, most absolute, and most terrifying truth. The reason why leaving the Milky Way is, and always will be, a one-way trip. The universe is expanding. We've known this since the 1920s. But it's not just that galaxies are flying away from each other. The very fabric of space-time between them is stretching. And, as we discovered in the late 1990s, this expansion is accelerating, pushed by a mysterious force we call dark energy. Inside a gravitationally bound system like a galaxy, gravity wins. But out in the void between galaxies, the expansion is unopposed. It's the dominant force. The rate of this expansion is measured by the Hubble constant. While the exact number is still being refined by astronomers, recent measurements place it around 70 kilometers per second per megaparsec. This means that for every 3 million light-years of distance, space itself is expanding at an additional 70 kilometers per second. When our starship was traveling away from the Milky Way, it was like a swimmer crossing a river. But this river gets wider and flows faster the farther you get from shore. As our ship traveled for millions of years, the space between it and the Milky Way was stretching the whole time. Now, the crew turns around, ready to go home. But the journey back isn't the same. The expansion of the universe is now a direct, unbeatable headwind. Our ship is fast, but it's trying to cross a gulf of space that is actively stretching against it. The Milky Way isn't a stationary target anymore. It's receding. At first, the effect is small. But as they travel, the accumulated stretching of space-time becomes more and more significant. They're running toward a finish line that is constantly and exponentially moving away from them. At a certain point, the accumulated expansion of space between the ship and the galaxy will mean the Milky Way is receding from them faster than the speed of light. This doesn't break Einstein's theory. No object is moving through space faster than light. It is space itself that is carrying the galaxy away. Once the Milky Way crosses this cosmic event horizon, relative to the ship, it becomes physically impossible to ever reach it again. You can't travel faster than light, and the very ground you're trying to cover is moving away faster than that. The light from home would still be visible, for a while, but it would be increasingly redshifted, its light waves stretched out by expanding space until it faded from visible light to infrared, to microwaves, and finally, into nothing. Home would literally fade away, erased from the sky by the universe itself. This is the final trap. You can leave the Milky Way, but the very act of leaving, and the time it takes, ensures the universe will change so fundamentally that you can never, ever go back. The prisoner's paradox. So, are we cosmic prisoners, locked inside the walls of our own galaxy? Maybe prison is the wrong word. A prison is something you want to escape. But what if the prison is, in fact, the entire habitable world? The Milky Way contains up to 400 billion stars. If each star had just one planet, that's 400 billion worlds to explore. It's a universe in itself. To see leaving it as the goal is maybe a failure of imagination. It's like owning a continent and only being obsessed with swimming to another one, ignoring the rich landscapes right at your feet. The horrifying truths of intergalactic travel aren't necessarily a curse. They're a clarification. They define the boundaries of our home. Our lonely messengers, the Voyager probes, will continue their silent, endless journey, trapped in their slow orbits around the galactic core. They will never report back. They are our first exiles, a testament to both our ambition and our limits. They teach us the final lesson. The greatest journey may not be to leave our galaxy, but to finally, truly understand and explore the one we're already in. Our future isn't in escaping the Milky Way, but in embracing it. Because for all of humanity, for all time, this galaxy is all the home we will ever have. If you made it to the end of this cosmic journey, thank you for watching. Exploring the limits of what's possible is what drives us forward. If you want to keep questioning the universe with us, make sure to subscribe and hit the notification bell. Part 2. How big the Milky Way really is. Before we go any farther, it helps to slow down. Because numbers like 100,000 light-years have a strange way of slipping past the mind. They sound large, certainly. They sound impressive, but they do not immediately feel real. A number that vast is too big to sit comfortably inside ordinary thought. It hovers there, abstract and distant, like something written on a chalkboard in a classroom rather than something you actually live inside. And that is the problem. If we are going to understand why leaving the Milky Way becomes a one-way trip, we first have to understand what the Milky Way actually is in terms that the mind can rest on. Not just as a label. Not just as a glittering band in the sky, but as a place, a structure, a home so enormous that even the fastest things in the universe cross it only with patience measured not in days, not in centuries, but in ages. Imagine standing at the edge of a great city at night. You see the lights stretching across the horizon, towers in the distance, roads disappearing into the dark. From where you stand, the city feels contained. You feel as if, with enough time, you could cross it. Maybe it would take a long drive, maybe a full night, but still, the idea feels human-sized, reachable. The Milky Way can trick us into the same feeling. We see that pale band of light in the sky and think of it as something visible, something bounded, something that can be understood from a single glance. But the Milky Way is not a city. It is more like an empire of stars. A vast rotating wilderness of light and gravity, with dark lanes of dust, invisible clouds of gas, and distances so enormous that language begins to thin out. From Earth, under very dark skies, the Milky Way appears as a soft river of whiteness spread across the heavens. People have called it many things over the centuries. A road of spirits, a celestial path, a scar of light. It looks delicate from down here, almost fragile. But what you are seeing is not a thin ribbon. It is the inside view of a galaxy. You are looking through the flattened disk of our home from within, like someone standing deep inside a forest and trying to understand the shape of the whole woodland by looking between trunks. That gentle band overhead is made of stars beyond counting. Not a few thousand, not even a few million. The Milky Way likely contains hundreds of billions of stars. Some are larger than our sun, some are smaller and dimmer. Some were born long before Earth existed. Some are probably gone already, their light still traveling. And between them lies vast, quiet emptiness. That emptiness matters. When people picture the galaxy, they often imagine a crowded sea of stars, all packed together like glitter in a jar. But space does not work that way. Even in the denser parts of the galaxy, stars are separated by astonishing distances. In our own neighborhood, the nearest star beyond the Sun is Proxima Centauri, and its light takes more than 4 years to reach us. Not 4 days. Not 4 months. More than 4 years, traveling at the fastest speed the universe allows. And that is just the next-door neighbor. It helps, sometimes, to begin with something smaller. Light from the Sun reaches Earth in about 8 minutes. When you step outside on a bright afternoon, the sunlight warming your face began its final journey toward you while your morning was still unfolding. Even inside our own solar system, light needs time. If the Sun were to vanish, Earth would continue orbiting and shining for about 8 minutes before the news reached us. Already, that is strange enough. Move farther out, and the distances quietly become more severe. Light from Jupiter takes tens of minutes to reach Earth depending on where the planets are in their orbits. Light from the outer reaches of the solar system takes hours. So even within the small family of the Sun, distance is not something you casually cross. It is something that imposes delay, separation, silence. Now stretch outward to the nearest stars, and the delay becomes years. Then stretch outward again to the Milky Way itself, and the scale becomes almost dreamlike. The bright stellar disk of the Milky Way is roughly 100,000 light-years across. Some estimates push that a little higher, some a little lower, but the point remains the same. A beam of light, moving at nearly 300,000 kilometers every second, would still need around 100,000 years to go from one side of the visible galactic disk to the other. 100,000 years. Let that sit for a moment. The whole of recorded human history is only a tiny fraction of that. Agriculture, cities, empires, writing, ships, clocks, engines, satellites, all of it fits into a sliver of time compared to what light itself needs just to cross the bright part of our home galaxy. If a ray of light had set out across the Milky Way when human beings were still painting caves and learning the seasons by memory, it still would not be finished. That is the kind of place you live in. And we are not even near the center. Our solar system sits in a quieter region of the galaxy, in a minor spiral arm often called the Orion Arm, or Orion Spur, roughly 26 to 27,000 light-years from the galactic center. That center is a far more crowded and violent region, packed with older stars, dense gas, and at its heart, a supermassive black hole known as Sagittarius A star. We do not live there. We live in what might be called the galactic suburbs, far from the brightest and busiest central districts, yet nowhere near the true edge. This is an important thing to feel. From Earth, it is easy to imagine that we are on some outer fringe, tucked near the boundary, with open darkness just beyond. But we are not perched on the doorstep. We are deeply embedded in the structure of the Milky Way. We are residents of the disk, surrounded by its scale in every direction. Even if you chose the most favorable route, even if you pointed away from the center and outward toward the rim, you would still be setting out across distances that do not care about human lifetimes. And the Milky Way is not shaped like a neat little circle with a bright line drawn around the outside. It is a barred spiral galaxy, which means there is a central bar-shaped structure of stars, with spiral arms sweeping outward from it. If you could rise far above it and look down, you would not see a tidy wheel. You would see a broad, luminous swirl, dusty and uneven, beautiful in a way that almost hurts. Star clouds would gather in bright knots. Dark bands of interstellar dust would cut through the glow. The arms would curve outward into the dimmer reaches, where stars thin out and darkness takes over more and more of the view. But we do not get that outside view. We get the inside one. And the inside view can be misleading. When you stand within something immense, distance compresses. Mountains on the horizon look reachable until you walk them. Cities seen from a hill look small until you enter their streets. The Milky Way overhead has the same effect. It looks like a feature of the sky. It is not. It is the environment itself. It is not decoration. It is geography. Even the thickness of the galactic disk, which sounds modest compared to its width, is enormous on human terms. The thin stellar disk is on the order of about 1,000 light-years thick in the region people often imagine crossing. That sounds small only because the width is so much larger. But 1,000 light-years is still a gulf beyond all ordinary understanding. Light would need a millennium to cross that thickness. Civilizations could rise, flourish, vanish, and leave no trace while light was still making its quiet passage from one side of that depth to the other. So when people imagine leaving the Milky Way by simply going up, out of the disk, there is already a deception in the mind. The word up feels short, direct, like climbing out of a valley. But galactic, up, still means traversing a cosmic distance beyond any human journey ever conceived. And as Part 1 already hinted, clearing the bright disk is only the beginning. The visible stars are not the full extent of where home still holds you. But even before the dark halo, even before the deeper trap of gravity, the visible galaxy alone is enough to humble the imagination. Consider our fastest spacecraft. Voyager 1, one of humanity's greatest long-distance messengers, has been traveling for decades. It has gone farther than any human-made object in history. It has crossed into interstellar space, beyond the heliosphere, into the thin material between stars. In human terms, its achievement is extraordinary. In galactic terms, it has barely stepped off the front porch. At its current speed, crossing the visible width of the Milky Way would take far longer than human beings have existed as a species. Not a long time. Not an impossibly long road trip. A span so vast that continents would change, stars would drift, and Earth itself would become a different world. And this is what makes the galaxy feel so eerie when you sit with it long enough. It is full of stars, yet mostly empty. It is full of motion, yet almost perfectly silent. Every star in it is moving, each on its own path around the galactic center, and yet the whole structure unfolds so slowly that it seems frozen. The Sun itself is orbiting the center of the Milky Way at tremendous speed, and still one full orbit takes roughly 225 to 250 million years. That means since the Sun was born, it has completed only around 20 galactic years. 20. Not 20,000. Not even 200. The entire history of our planet, with all its oceans, dinosaurs, extinctions, forests, and civilizations, fits inside roughly 20 revolutions around the Milky Way. It is hard to think of a better reminder that human history is not just brief. It is almost unbelievably brief. And still, for all this scale, the galaxy is not packed shoulder to shoulder with starlight. Most of any journey through the Milky Way would not be a tour through glowing constellations. It would be a voyage through darkness. A ship leaving the Sun would spend years reaching even the nearest stars. Then more years. Then centuries. Then millennia. Vast stretches would pass with almost nothing changing to the eye except the slow rearrangement of distant lights. This is another quiet misunderstanding people have about outer space. They imagine movement through it as movement through scenery. But the galaxy is not a painted backdrop sliding past a window. Most of the time, it is separation. Gaps. Distances so wide that one solar system can live and die without ever touching the next. And yet, despite that emptiness, the Milky Way remains a coherent thing. A structure bound together by gravity. Not just a random scattering of lights, but a true system, rotating and shaped by mass both visible and invisible. Dust clouds collapse into new stars. Old stars drift and age. Supernovae seed the galaxy with heavier elements. Giant molecular clouds move through the spiral arms. The center blazes more fiercely. The outer regions thin and fade. It is a city only in metaphor. In reality, it is a living gravitational landscape. There is a certain calm in realizing this. The night sky stops being a ceiling and starts becoming depth. The stars stop being pinpricks and become distant suns inside an architecture too large to hold in the mind all at once. The Milky Way stops being a pretty background to human life and becomes what it really is, the vast rotating home that made our existence possible. Every atom in your body that was forged in an ancient star was forged somewhere inside a galaxy like this. Every sunrise you have ever seen has happened inside this broad spinning disk. Every human hope, every city light, every whispered prayer, every ship launched into the dark, all of it has happened in one tiny neighborhood of one galaxy among many. And that tiny neighborhood, to us, is everything. This is why leaving begins to feel different once you truly understand the scale. It stops sounding like a voyage and starts sounding like estrangement. The farther you imagine going, the more the galaxy changes from a destination behind you into an entire reality slowly shrinking away. Not just Earth, not just the Sun, the whole star field of home, the familiar background of our cosmic life. And if you are enjoying the calm of this journey so far, you can always leave a quiet like, subscribe to the channel, and share in the comments where you're listening from tonight. It is always strangely comforting to remember that while we are talking about distances beyond imagination, people are hearing these thoughts from bedrooms, cities, coastlines, and quiet corners all across one very small planet. Now, there is one last layer to this. Even the visible Milky Way, the great shining disk, is not the whole story. It is the part our eyes and telescopes can most easily fall in love with. But galaxies do not end where the starlight seems to thin away. There are older outer stars, sparse globular clusters, diffuse gas, and beyond all of that, the far more mysterious mass that Part 1 introduced, the dark matter halo. In other words, even once you think you have understood the size of home, home keeps extending outward into darkness. This is what makes the phrase one-way trip so haunting. To leave the Milky Way is not simply to fly away from a bright patch of stars until it becomes smaller behind you. It is to try to escape a structure so large that its visible face alone defeats ordinary imagination, and whose true reach goes far beyond what the eye can see. The first shock is not just how hard escape would be. The first shock is realizing how deeply inside you already are. You were never standing at the edge. You were born in the interior of something ancient and vast. A galaxy with spiral arms wider than history, with stars numbering in the hundreds of billions, with distances that make even light seem patient. To understand the Milky Way is to understand that home, on the largest scale that still means anything to us, is not small. It is not local. It is a continent of suns, an ocean of darkness and fire, and we are living in one quiet inlet of it. So before we ask what it would take to leave, we have to carry this feeling with us. The Milky Way is not a backdrop. It is not a nearby object. It is a vast and difficult place. And every plan to escape it begins with the same humbling truth. The journey out is already unimaginably long before you even reach the real boundary. Part 3, Where Earth Sits in the Milky Way. Now that we have slowed down enough to feel the size of the Milky Way, there is another question waiting for us, and it is a more intimate one. Where, exactly, are we inside it? Not in the poetic sense. Not in the sense of saying we live under the stars, or somewhere in the galaxy, or on a small world in a vast universe. But in the real, physical sense. If the Milky Way is our home, then where is our address? Are we near the center, where the galaxy burns brightest? Are we close to the edge, where the stars begin to thin into darkness? Are we in some privileged place, or in some forgotten corner that most of the galaxy would barely notice? The answer is strangely calming. We are not at the center of anything. We are not at the edge either. We are somewhere in between, in a quiet district of a galaxy so large that even describing our location requires patience. We live in a modest stellar neighborhood, circling the galactic center from far away, tucked inside one of the Milky Way's spiral structures, in a region that is neither too crowded nor too empty. It is not the grandest place in the galaxy, but it may be one of the reasons we are here at all. If you could rise far above the Milky Way and look down on it from outside, you would see a barred spiral galaxy. At its heart would be a bright central bulge, thick with stars, glowing more densely than the outskirts. Stretching through that center is a bar-shaped structure, and from it curl the spiral arms, broad and graceful, sweeping outward like luminous weather patterns frozen in slow motion. Clouds of gas and dust would drift through the arms. Blue-white young stars would mark places where new suns are being born. Older golden stars would gather in the bulge and halo. And somewhere, not especially close to the center and not especially near the rim, would be a small yellow star with a few planets circling it. One of those planets would be Earth. That small star is the Sun. And our location, though ordinary on cosmic terms, is more specific than many people realize. The solar system sits about 26 to 27,000 light-years from the center of the Milky Way. Different measurements may nudge that number slightly, but the picture remains the same. We are well out from the middle, yet still deeply inside the galaxy's disk. If the visible Milky Way is roughly 100,000 light-years across, then we are not living in the center of the great spiral city, but neither are we living at its last lonely streetlight. We are out in the broader suburbs, still surrounded by the structure of home. This matters because our imagination often cheats. It hears that we are far from the center, and quietly translates that into near the edge. But the two are not the same. Far from the center in galactic terms can still mean very deep inside. A person standing halfway across a continent is far from the capital, but still nowhere near the ocean. That is closer to our situation. We are far from the crowded heart of the Milky Way, but we are not perched at the boundary looking out into intergalactic darkness. We are residents of the interior. And our particular neighborhood has a name. Or rather, several names, because astronomy often carries a trail of overlapping labels. We are usually said to be in the Orion Arm, or the Orion Spur. More precisely, this is a smaller spiral feature located between two larger arms, the Sagittarius Arm and the Perseus Arm. So we are not even sitting in one of the Milky Way's grandest, most dramatic spiral arms. We are in a quieter spur between them, a kind of secondary branch. It is not a cosmic highway. It is a calmer stretch of the galactic map. That image feels right somehow. Human beings often assume importance. We once thought Earth was the center of the universe. Then we thought perhaps the Sun held some privileged place among the stars. But the deeper astronomy looks, the more it reveals a gentler truth. We do not seem to occupy a special throne in the cosmos. We live in a fairly ordinary region around a fairly ordinary star in a fairly ordinary part of one galaxy among many. And rather than making life smaller, that realization makes it more peaceful. We are not under the spotlight. We are part of the quiet fabric of things. Still, ordinary does not mean simple. Our local region of the galaxy is filled with structure. The nearest stars are not arranged in neat rows or evenly spaced circles. They drift in three-dimensional space, each with its own speed and history. Some belong to loose-moving groups. Some were born together in the same cloud and are slowly drifting apart. Some are visitors from other regions of the disk, passing through over millions of years. The Sun is not parked in a fixed position inside the Milky Way like a street lamp bolted into a sidewalk. It is moving. Everything is moving. The Earth circles the Sun. The Sun, carrying Earth with it, circles the center of the Milky Way. And the Milky Way itself is moving through the local group of galaxies. Once you start noticing these layers of motion, there is a strange comfort in them. Even on the stillest night, nothing is truly still. The Sun travels around the galactic center at roughly 220 kilometers per second, give or take, depending on how one measures the local motion. That sounds astonishing, and it is. We are all moving through the galaxy far faster than any aircraft, faster than any storm, faster than anything in daily life can prepare us to imagine. And yet we do not feel it, because everything around us is moving together. The Earth, the atmosphere, the oceans, your body, your room, all are sharing that motion in silence. At that speed, one orbit around the Milky Way takes something like 225 to 250 million years. This is sometimes called a cosmic year, or a galactic year. It means that since the age of the dinosaurs, the solar system has gone around the galactic center only about once. Since modern humans emerged, we have traveled only a tiny fraction of one galactic orbit. The whole of human civilization, from the first cities to satellites and telescopes, has unfolded during a barely noticeable turn in the wider path of the Sun. And this tells you something important about where we live. We do not inhabit a fast-changing environment on human timescales. The galaxy is dynamic, yes, but it changes with immense patience. Spiral arms shift. Stars migrate. Gas clouds collapse and disperse. Supernovae explode and enrich the interstellar medium. But much of this happens across spans of time so long that a human life, even all of human history together, appears almost motionless by comparison. That is one of the hidden reasons the sky can feel eternal. It is not eternal, but it changes slowly enough to give that illusion. Our specific region may also be unusually kind to life. If Earth had formed much closer to the galactic center, conditions could have been harsher. The central regions of the Milky Way are more crowded. Stars are packed more densely there. Supernovae may be more frequent. Radiation environments may be more intense. Gravitational interactions between stars can be more disruptive over long timescales. It is a beautiful region from a distance, but perhaps not the calmest place to build a stable planetary story over billions of years. Farther out, near the sparse outskirts of the galaxy, there can be a different problem. Some regions may contain fewer of the heavier elements needed to build rocky planets and complex chemistry. The earliest stars formed mostly from hydrogen and helium, and only later generations enriched the galaxy with carbon, oxygen, silicon, iron, and other elements forged inside stars and scattered by stellar death. Life as we know it depends on that cosmic recycling. Too close to the center, and the neighborhood may be too violent. Too far out, and there may once have been too little of the material needed to build worlds like ours. Where we are, by contrast, seems to occupy a relatively gentle middle ground. Astronomers sometimes talk about a galactic habitable zone, not as a sharply defined band, but as a general idea that some regions of a galaxy may be more favorable for long-term planetary stability and chemistry than others. The Sun's location appears to fit that idea reasonably well. We are in a region rich enough in heavy elements to have produced rocky planets, yet far enough from the central crowding to allow long stretches of relative stability. There is something quietly humbling in that. Not destiny, not design, just circumstance unfolding inside physics. A certain distance from the center. A certain generation of stars. A certain cloud of gas enriched by older suns. And eventually, on one small planet, oceans, atmosphere, chemistry, cells, memory, language, and people who could ask where they were. Even our immediate interstellar surroundings are gentler than they might have been. The solar system appears to lie within a region known as the local bubble, a cavity of hot, low-density gas carved out long ago by ancient supernovae. It is not an empty void, but it is thinner than some neighboring regions. Around us, scattered within dozens of light years, are the stars of our local stellar neighborhood. Proxima Centauri, Alpha Centauri A and B, Barnard's star, Sirius, Epsilon Eridani, and many others. Some are red dwarfs, dim and long-lived. Some are brighter and more massive. Many almost certainly have planets. These are our nearby houses on the galactic street, though even the closest are separated by distances that make travel painfully difficult. This is worth lingering on, because when people hear that Earth is inside the Milky Way, they sometimes imagine the galaxy as a crowded lantern festival, each star alight hanging close to the next. But our local neighborhood is more like a dark countryside with farmhouses scattered over immense distances. There is company out there, yes. But between one house and the next lies a great deal of night. The Sun itself is also a fairly ordinary star, and that ordinariness may be one of the best things about it. It is not a giant blue star burning its fuel recklessly in a few million years. It is not a red dwarf prone to violent flares of the kind that might strip atmospheres from nearby planets. It is a stable, middle-aged yellow star, a G-type main sequence star, living the kind of slow, dependable life that gives biology time to experiment. It formed about 4.6 billion years ago, already inside a galaxy that had been evolving for billions of years before it ever existed. It inherited material from older stars, and in doing so became part of a chain older than the solar system itself. So when we ask where Earth sits in the Milky Way, the answer is not just a coordinate. It is a story of condition. We sit in a comparatively calm outer region of the disk, in a minor spiral structure, orbiting far from the central black hole and dense bulge, inside a long-lived stellar neighborhood where enough time and enough raw material were available for complexity to emerge. And still, we are not fixed. The Sun bobs slightly up and down through the galactic plane over immense timescales. It drifts relative to nearby stars. Over millions of years, the constellations themselves slowly deform. Orion, Ursa Major, Scorpius, all the familiar patterns of the sky, are temporary. Given enough time, the stars that seem arranged so beautifully to us now will no longer resemble the figures we inherited from the past. The sky feels ancient, but even it is not permanent. Perhaps that is one of the reasons the topic of leaving the Milky Way feels so haunting. It is not just that the galaxy is large. It is that our position inside it is living, moving, and yet deeply embedded. We are already on a journey without noticing it. Earth is not parked in the Milky Way like a pebble on a shelf. It is being carried around the galaxy in a silent orbit, all of us passengers on a path so long that whole branches of life appear and vanish before the curve becomes obvious. Now imagine trying to leave from where we are. You are not launching from the edge of a map. You are starting from a place tens of thousands of light years from the center, inside a moving disk, inside a gravitational system, from a star that is itself racing around the Milky Way. The direction you choose matters. If you aimed inward, toward the galactic center, you would be heading into denser and more violent territory. If you aimed along the plane of the disk, you would remain entangled with its broader structure for longer. If you aimed above or below the disk, you might leave the bright stellar band more quickly, but not the galaxy's deeper grip. Every route begins from the same truth: we are inside, not near the door. This makes our location emotionally different from how science fiction often frames it. In stories, a ship lifts off, crosses a threshold, and soon the familiar galaxy lies behind like a postcard fading in the distance. But from our true position, any real departure would be slow almost beyond language. The Sun would remain part of home long after Earth was gone from sight. Nearby stars would remain neighbors for centuries, then for millennia. The broad glow of the Milky Way would continue to fill half the sky. Home would not disappear all at once. It would take ages to loosen. And that is perhaps the loneliest part of all. Because there is something sadder about a goodbye that stretches over thousands of years. Not a dramatic severing, but a gradual thinning. A familiar pattern fading with almost unbearable patience. A ship leaving Earth would first lose continents, then the Sun would become just another star, then the local constellations would slowly distort, and only much later would the shape of the Milky Way itself begin to change in a way that felt final. Leaving the galaxy would not feel like stepping through a gate. It would feel like watching home recede so slowly that generations might still call it near. And yet, even with all that scale, we can still take comfort in knowing where we are. Our address in the cosmos is not precise in the way a street address is, but it is real enough to imagine. We live on a rocky planet orbiting an ordinary star in the Orion Spur, around 27,000 light-years from the galactic center. Inside the disk of the Milky Way, far from the central blaze, in one quiet district of a spiral galaxy that has been turning for billions of years. That is not a small thing to know. People once lived beneath the stars without any sense of their true arrangement. The Milky Way was a mystery, a luminous fog, a mythic road. To know now that it is our galaxy, to know roughly where we sit within it, to know that our sun circles its center in a slow cosmic year, is one of the gentle triumphs of human thought. We may be small, but we have learned enough to place ourselves. We have looked into the night and found our location, not in an emotional sense, but in a structural one. And there is a kind of dignity in that. If this slow journey through the galaxy is helping you unwind, you can quietly subscribe, leave a like, or share where in the world you're listening from tonight. It is always a little beautiful to imagine all of us scattered across one planet, each in a different room or city, while thinking together about a home that is 27,000 light-years deep around us. So now we know the setting. We know that Earth does not sit at the center of the Milky Way, and we know it does not wait near the rim. We know we live in a calmer, outer region, on a modest branch between larger spiral arms, carried around the galaxy by the sun in a journey so slow it barely registers against a human life. We know our neighborhood is spacious, quiet, and perhaps one of the reasons life had the chance to become reflective here. But knowing where we are leads naturally to the next problem. Because once you understand that we are tens of thousands of light years inside the Milky Way, another question appears almost immediately. If this is our starting point, then how fast would you have to go to ever leave it behind? That is where the dream begins to collide with physics. And that is where the real difficulty starts. Part 4, the speed problem. The trouble begins with a very simple word: fast. In ordinary life, it feels easy to understand. A fast car, a fast train, a fast internet connection, even a fast airplane still belongs to the same world of human timing. You leave in the morning and arrive by evening. You wait a few hours, maybe a few days, and that still feels normal. Fast, in the world we are used to, is something that shrinks distance into convenience. It turns a difficult journey into an ordinary one. It makes the world feel smaller. But space does not care what feels fast to us. That is the quiet shock waiting at the center of this story. Because once you truly understand where Earth sits inside the Milky Way, the next thought seems obvious. Fine. We are deep inside the galaxy. Fine. The distances are vast. But what if one day we build something unimaginably fast? What if human technology keeps improving? What if the problem is not distance, but only patience? Surely, at some point, speed saves us. And the answer, unfortunately, is that speed helps much less than intuition wants it to. Not because speed is unimportant. It is essential. But because the scale of the Milky Way is so severe that even astonishing speed can still leave you trapped inside a journey that no civilization could experience as ordinary. In the galaxy, the problem is not just movement. It is the relationship between movement and distance. And the ratio is brutal. It helps to begin at home. Earth moves around the sun at around 30 kilometers per second. That is already much faster than anything we feel in daily life. At that speed, if roads worked that way, you could circle the world in a matter of minutes. The sun, in turn, carries the entire solar system around the Milky Way at roughly 220 kilometers per second. Again, an extraordinary speed. If human intuition ruled the universe, numbers like that should make the galaxy feel small and manageable. But they do not. Because even those enormous speeds are moving across distances so large that they barely seem to matter. Light, the fastest thing we know, travels at about 300,000 kilometers per second. Every second, it covers enough distance to circle Earth more than 7 times. It rushes from the Sun to Earth in around 8 minutes. It crosses the orbit of Neptune in a few hours. By every standard available to ordinary thought, light is absurdly fast. And yet light itself takes more than 4 years to reach the nearest star beyond the Sun. This is where the mind begins to stumble. Not because the information is hard, but because the emotional meaning of it is hard to hold. A signal traveling at the absolute speed limit of the universe still needs years to cross even the nearest gap between stars. So what, then, would a human spacecraft do? What would it mean to leave not just the solar system, but the Milky Way itself? This is where the speed problem stops being a technical issue and starts becoming a kind of existential one. Because the galaxy is not just big. It is big in a way that defeats the scale of biological life. It is larger than generations, larger than empires, larger than languages, larger than the continuity of almost any culture that has ever existed. Suppose you built a ship that could travel faster than anything humanity has ever made. Not a rocket in today's sense, not a fragile machine meant for months or years, but something far beyond that. A true interstellar craft. A vessel designed for the dark between stars. Even then, the numbers remain merciless. Take Voyager 1, one of the furthest human-made objects ever sent into space. It has been traveling for decades, moving at around 17 kilometers per second relative to the Sun. In human terms, that is an astonishing speed. It left Earth in 1977, long before much of modern digital life even existed, and it is still making its way outward, carrying our small golden record into the dark. It has already gone farther than any human artifact ever has. And yet, on the scale of the galaxy, Voyager is barely beginning. At that speed, reaching even 1 light-year takes roughly 18,000 years. Not crossing the galaxy. Not reaching a distant spiral arm. Just 1 light-year. And the Milky Way is not 1 light-year across. It is about 100,000 light-years across in visible diameter, and even that is not the whole story. So suddenly the idea of leaving begins to change shape. It is not like crossing an ocean. It is not even like crossing the solar system. It is like trying to cross a continent grain by grain, while every grain is separated by centuries. And perhaps the most unsettling part is how quickly our pride collapses in the face of this. Human beings are used to progress, used to improvement, used to inventions that make the impossible become ordinary. There was a time when crossing an ocean took months of danger, and then came engines, aircraft, satellites. So it is natural to think that the same story will continue forever. The galaxy is only impossible until it is not. That is the hope. But space has a way of exposing the hidden limits of that hope. Because yes, we can imagine speeds greater than Voyager's. Much greater. Suppose, for the sake of calm thought, we imagine a future ship traveling at 1% of the speed of light. That would be around 3,000 kilometers per second. Far beyond anything our current spacecraft sustain as a cruising speed for long journeys. A tremendous leap. A machine so advanced that, by our present standards, it would already feel almost mythic. And yet at 1% of light speed, 1 light year still takes about 100 years. 100 years for 1 light year. The nearest star would still be centuries away. 1,000 light years, enough only to rise roughly through the thinner scale of the visible disk in one direction, would still mean 100,000 years. The broad width of the Milky Way would remain a journey measured not in exploration, but in geological patience. Maybe then we push farther. Maybe not 1% of light speed, but 10%. Now we are talking about truly staggering velocity. Now we are in the range that science fiction often takes for granted. At 10% of the speed of light, 1 light year takes roughly 10 years. That is better. Much better. Distances that once belonged to prehistory begin to enter the realm of long missions, long lives, or generations. But now notice what has happened. We had to imagine a ship moving at 10% of the fastest speed the universe allows just to make the nearest stars feel remotely reachable. Not easy. Not casual. Reachable. And even then, the galaxy itself remains crushingly large. 10% of light speed means the visible width of the Milky Way still demands around 1,000,000 years to cross. 1,000,000 years. That is the kind of number that empties a room. It does not sound like travel anymore. It sounds like erosion. It sounds like the life cycle of species. It sounds like something the Earth does, not something a ship does. Even if you cut across smaller paths, even if you aim not for one side of the galaxy to the other but simply away from where you began, you are still contending with distances that turn extraordinary speed into a long fading exile. And this is before we even confront the deeper issue that comes next, which is gravity. For now, just stay with speed. Just stay with the raw arithmetic of motion. There is a quiet cruelty in it, because speed is the one solution human imagination reaches for first. We can survive with enough supplies. We can engineer around danger. We can plan for radiation, for systems, for structure, for life support. But if speed itself is not enough, then everything else begins to feel secondary. A perfect ship traveling too slowly is not a ship. It is a drifting inheritance. This is why the dream of leaving the Milky Way so easily becomes a dream of generations instead of people. If the trip cannot fit inside a lifetime, then the traveler changes. The mission stops being yours. It becomes your descendants. Then their descendants. Then eventually it becomes a culture floating inside a machine. A moving society. A memory of departure carried forward by people who did not choose it. And that only happens if speed remains too low. But perhaps, you might say, the future will not stop at 10% of light speed. Perhaps one day we get closer. 50%, 90%, 99%. And now we arrive at the most famous wall in physics. The speed of light is not just a very high number. It is a boundary woven into the structure of reality. The closer an object with mass gets to light speed, the more energy is required to push it any further. Not a little more. Not proportionally more. More and more, in a rising demand that becomes punishing. To actually reach the speed of light, an object with mass would require infinite energy. And the universe does not seem to offer that. This is one of those scientific truths that sounds abstract until you let it settle. It means there is no final heroic push. No last burst of engine power that takes a starship from almost enough to completely free. Nature has written a limit into the rules. You may approach it. You may come close enough for time and distance to begin behaving strangely. But for anything made of matter, for ships and bodies and bones and machines, the absolute speed of light remains out of reach. And still, even approaching it changes the story. If a ship could somehow reach 90% of light speed, or 99, the distances would begin to shrink in a meaningful way from the perspective of outside observers. A trip that once required millennia might require decades or centuries. But notice what kind of technology we are already assuming. Not a better rocket. Not an improved engine. We are assuming a civilization capable of handling energies so vast that our entire industrial history begins to look primitive. This is why the speed problem is so unsettling. It is not merely asking us to improve. It is asking us to become something almost unrecognizable to ourselves. And even then, the emotional cost does not disappear. Because traveling at such speeds changes more than the distance between places. It changes time itself. As a ship moves closer to light speed, strange effects predicted by Einstein's relativity begin to matter. Time for the travelers can pass differently from time for those left behind. To the crew, the voyage might feel shorter than it does to the rest of the universe. What seems like a solution carries another sadness hidden inside it. You may shorten the journey for yourself only by deepening the separation from home. You leave one era and return, if you return at all, to another. But that fuller horror belongs a little later. For now, even without leaning on relativity too heavily, the message is already clear enough. The Milky Way is so large that our everyday idea of speed becomes almost meaningless inside it. A car is fast on a road. A plane is fast across a country. A spacecraft can be fast within a planetary system. But the galaxy is a different category of reality. There, fast is not what feels impressive. Fast is what survives the arithmetic. and almost nothing we can presently imagine survives it comfortably. It helps, sometimes, to picture the galaxy not as a glowing object in the sky, but as a dark plain with scattered fires. Each fire is a star. Between one fire and the next, immense cold distance. A traveler can run. A traveler can build a better vehicle. A traveler can sacrifice, optimize, calculate. But if the plane itself is vast enough, all speed begins to feel like a form of waiting. And there is another quiet problem hidden inside the word fast: acceleration. We often talk as if a ship simply has a speed, as if it can exist at a number the way a thought exists in the mind. But real journeys require reaching that speed. That means fuel, thrust, heat, engineering, structure, time. You do not simply declare that a vessel goes at 10% of light speed. You must push it there. Then perhaps you must slow it again. The faster the target speed, the harder the practical burden becomes. Speed is not just a destination. It is a process, and that process has a cost. The deeper you think about this, the lonelier the dream begins to feel. Not because it is impossible in the narrow sense. Science rarely rewards that kind of certainty. But because each improvement seems to reveal another hidden wall behind it. Better rockets lead to interplanetary scale. Better propulsion leads to interstellar thought. But galactic scale remains so wide, so patient, so indifferent, that it keeps asking the same question in different forms. Fast for whom? Fast by what measure? Fast enough to matter before everything you love has changed? That is the question that gives this whole topic its strange emotional power. Leaving the Milky Way is not difficult in the same way climbing a mountain is difficult. It is difficult in a quieter, sadder way. You do not merely need courage. You need a speed so great that it threatens the continuity of human meaning. If a trip takes 10,000 years, who is it really for? If it takes 1,000, what is home by the time you arrive? If it takes 100, how much of the world you left is still waiting? Even the optimistic numbers carry loss inside them. And yet, there is something almost beautiful in facing this honestly. Because the numbers do not just tell us what we cannot do. They tell us what kind of place the Milky Way really is. A home so vast that leaving it is not a weekend fantasy but a confrontation with the deepest laws of time, distance, and energy. A place where even light needs years to cross local gaps, and where ships would have to become miracles just to make departure feel conceivable. If this slow journey through the cosmos is helping you unwind, you can quietly leave a like, subscribe, or share where you're listening from tonight. There is something comforting in that thought too. People on one small planet, scattered across cities and quiet rooms, listening together while the galaxy turns around us. So this is the speed problem. Not that motion is impossible. Not that technology can never improve. But that the scale is so immense that speed alone does not rescue the dream in any easy way. The Milky Way is simply too large for ordinary definitions of fast. To leave it, you would need more than a good ship. More than a brave crew. More than even a civilization's confidence. You would need a way of moving that can stand up to cosmic distance without collapsing into absurd time. And once you have understood that, the next question becomes unavoidable. Because speed is only half the trap. Even if you could move astonishingly fast, there is still something else holding you here. Something older, quieter, and harder to argue with. Gravity. That is where the journey becomes even more difficult. Part 5. The gravity of the Milky Way. There is a reason leaving the Milky Way feels so much easier in the imagination than it does in reality. From a distance, or at least from the distance of thought, a galaxy looks like a picture. A swirl of stars. A bright wheel suspended in darkness. Something beautiful, certainly, but also something flat and almost decorative, as if it were a pattern painted on the inside of the sky. And if something looks like a picture, then it is easy to assume you can simply move away from it. You point in the opposite direction, keep going long enough, and eventually the picture gets smaller behind you. But the Milky Way is not a picture. It is not a wallpaper of stars hanging motionless in space. It is a gravitational system. A vast, structured, invisible grip of mass and motion. Every star you see, every cloud of gas, every wandering comet, every dark and distant object inside it is part of a relationship. Nothing is simply sitting there. Everything is falling. Everything is being held. And that changes the whole feeling of the journey. Because once you understand speed, the next hope comes very naturally. Fine, the distances are terrible. Fine, reaching the outer parts of the galaxy would take longer than most human minds are comfortable imagining. But perhaps that is just a matter of endurance. Perhaps it is only a matter of going far enough, fast enough, for long enough. Perhaps the Milky Way is just big, but gravity turns that big place into something else. It turns it into a kind of well. Not a well of stone with clear walls and water at the bottom, but a gravitational well. A region of space where mass has bent the rules of motion so thoroughly that everything inside it is always paying a kind of invisible tax. The deeper you are inside, the harder it is to leave. The more massive the system, the more difficult escape becomes. You are not just traveling through a place. You are climbing out of it. This is one of the strange truths of astronomy. Space often looks empty, but emptiness does not mean freedom. A region can seem open, quiet, almost limitless, and still be ruled by a force you cannot see. Here on Earth, gravity feels familiar. It is the force that keeps your feet on the ground, the force that makes rain fall, oceans gather, and thrown objects come back down. We are so used to it that we almost forget it is there until something resists it, a bird lifting off, an elevator moving, a rocket rising on a pillar of flame. And even then, Earth's gravity has an ordinary quality in our minds. It belongs to daily life. It belongs to apples, staircases, and the soft weight of blankets. But gravity does not stop at planets. The moon is held by Earth's gravity. Earth is held by the sun's gravity. The sun is held by the gravity of the Milky Way. And the Milky Way itself is held together by the combined mass of everything inside it, visible and invisible. So when we talk about leaving the galaxy, we are not talking about drifting away from a neighborhood. We are talking about escaping a force field built by hundreds of billions of stars, enormous clouds of gas, ancient star clusters, compact remnants, and a great deal of unseen mass that reveals itself only through its pull. That is the part that quietly changes everything. Because if the Milky Way were only a loose gathering of lights, then perhaps leaving would mostly be about distance. You would just go and go until the lights thinned out behind you. But it is not loose. It is bound. Bound so strongly, in fact, that the sun itself races around the galactic center at immense speed and still remains trapped within the larger structure. That motion we talked about earlier, the solar system moving at more than 200 kilometers per second around the center of the galaxy, is not freedom. It is captivity in motion. We are not flying away. We are circling. And circling is a very different thing. A planet in orbit around a star is perpetually falling toward it, but moving sideways fast enough to keep missing. That is what an orbit really is. A long, graceful failure to fall straight down. The same idea holds on larger scales. The sun is not fixed in place by the Milky Way. It is falling through the galaxy's gravitational landscape in a controlled and continuous curve. Every star in the disk is doing something like that, each following its own path through a system too large to see from the inside. So even before a spaceship tries to leave, it begins in motion. It begins already committed to the wider dynamics of the galaxy. It begins deep inside a moving river of gravity. This is why the word escape becomes so important. In physics, escape does not mean getting far away in a casual sense. It means having enough energy to break free from a gravitational system entirely, so that you never fall back. Earth has an escape velocity. The moon has one. The sun has one. And the Milky Way has one too. That phrase, escape velocity, sounds almost cinematic. But what it really means is simpler and more merciless. It is the minimum speed needed to get out without eventually being pulled back. If you throw a stone upward from Earth, it rises and falls. Throw it harder, and it rises higher, but still falls. Throw it faster than about 11.2 kilometers per second, ignoring the atmosphere and many practical complications, and it can break free from Earth's grip. That is escape velocity. It is not about looking like you are leaving. It is about whether gravity still owns your future. The galaxy works the same way, only on a far grander scale. From our region of the Milky Way, the escape velocity is estimated to be around 550 kilometers per second, give or take depending on the model and local conditions. That is not the cruising speed of some futuristic luxury vessel. That is the threshold for truly breaking free from the galaxy's gravitational hold. If you are below it, then no matter how triumphant your departure may feel at first, gravity is still writing the ending of your story. And this is where the quiet horror begins to deepen. Because 550 kilometers per second is not just fast. It is staggeringly fast. Much faster than anything humanity has built to cruise through interstellar space. Voyager 1, our most distant emissary, moves at only a small fraction of that. It is fast enough to leave the planets behind, fast enough to enter interstellar space, fast enough to become a tiny human-made myth drifting among the stars. But it is not fast enough to leave the Milky Way. Not truly. Over immense timescales, it remains a prisoner of the galaxy. That is one of the most haunting things about the Voyager probes. We often imagine them as escaping into the great beyond, leaving the solar system and then the galaxy behind like drifting bottles in an endless sea. But in truth, they are still inside the larger cage. They are not headed into freedom. They are tracing long futures inside a system so large that even exile remains local. And so would we. A ship could leave Earth. It could leave the solar system. It could leave the local stars behind. It could even rise beyond the bright band of the galactic disk. And still, gravity might be quietly telling a different story beneath all of that apparent success. Because leaving the visible part of a thing is not the same as escaping the thing itself. It helps to imagine climbing a mountain at night. At first, you leave behind the lights of the village below. Then the roads disappear. Then the trees thin. Then even the sounds of ordinary life fade into the cold. You might feel as though you have left the world. But the mountain is still beneath your feet the entire time. Every step upward is still part of the same terrain. You have not escaped gravity merely because the familiar scenery is gone. The Milky Way is like that, only far stranger. Its bright stars are what we notice first, but its true power lies in the mass holding them all together. The galaxy is a landscape made not only of light, but of pull. That pull extends far beyond what the eye would ever guess. Even the stars at the far reaches of the visible disk are moving in ways that reveal something deeper, something heavier, something unseen. They orbit too fast for the visible mass alone to explain. That mystery, as Part 1 introduced, led astronomers to the idea of dark matter, the great invisible halo surrounding the galaxy. But even before we fully return to that larger invisible territory, the visible mass alone already gives us enough to understand the emotional shape of the problem. The Milky Way is not a border you cross. It is a field you must escape. And fields are deceptive. You cannot see them directly. You only notice what they do. You do not see Earth's gravity hanging in the air. You see rain falling. You see rivers flowing downhill. You see the arc of a thrown ball. In the same way, you do not see galactic gravity as a glowing substance stretched across the stars. You see stars orbiting where they should not be able to orbit. You see clouds held together. You see the sun spending hundreds of millions of years circling the center instead of flying off into the dark. That is the evidence of the cage. And there is something almost eerie in the calmness of it. No bars. No walls. No sound. Just motion that never quite becomes freedom. This also means that any journey outward is harder than it first appears, because gravity is not merely an obstacle at the beginning. It is not like a gate you break through once and leave behind. It accompanies you. It pulls on you the entire time. Every kilometer outward is a climb against a system that would prefer to keep you bound. To leave the Milky Way is not simply to cover a distance. It is to spend that distance fighting a pull that never fully stops until you are truly free. And that raises a difficult question. What does it mean to be truly free of the Milky Way? It means more than being far away from the sun, more than losing sight of familiar constellations, more than watching the bright disk shrink into a luminous smear behind you. True escape means that if your engines failed, if you stopped pushing entirely, you would still not fall back. Your future would no longer belong to the gravitational logic of the galaxy. That is the real threshold. Not the moment home looks distant, but the moment home no longer owns your path. That is a much harder threshold to cross than emotion would suggest. Because distance can fool you. Even now, we live far from the center of the galaxy, and yet we are securely trapped within it. Far is not the same as free. There is also a more intimate sadness hidden inside gravity. It means that home is not just a place behind you. It is a force acting on you. Even when you try to leave, home continues to reach out and shape your motion. The galaxy is not merely where you came from. It is part of the physical structure defining where you can go, how fast you must travel, how much energy you need, and whether your departure is real or only temporary. That is a much deeper kind of attachment than most journeys involve. When people leave a city, the city does not pull them back with literal force. When people sail away from a shore, the shore recedes without trying to keep them. But the Milky Way is different. It has mass, and mass means gravity, and gravity means departure is always an argument. It is also worth remembering that gravity is patient. It does not need to act dramatically to win. It can succeed over millions of years with the gentlest persistence. A small difference in speed, a slight shortfall in energy, a trajectory that looks promising at first. Given enough time, gravity can turn almost escape into a vast looping return. In a universe built on long timescales, patience is power. This is why even a very fast ship could still fail in the deepest sense. It might travel for centuries, for millennia, through the outer dark. It might pass the last major stars of the disk and enter regions where home feels already abstract. The crew, if there were a crew, might believe they had succeeded. The galaxy might be only a bright wound of light behind them. But if the ship had not truly crossed the threshold of escape, then all that apparent victory would still be unfolding inside one long gravitational sentence. And that is such a haunting thought. To feel free and yet not be free. To believe you have left, while the galaxy quietly disagrees. Perhaps that is why this subject has a different emotional texture from ordinary science. It is not just about numbers or engines or maps. It is about thresholds that are harder to perceive than we expect. It is about the difference between seeming and being, between distance and release, between watching home grow small and actually escaping its influence. And the Milky Way has another advantage over us. It is ancient. Long before the sun formed, long before Earth cooled, long before life learned to divide and crawl and breathe, the galaxy was already here, shaping motion through gravity. Countless stars have orbited within it. Some were born, lived, and died before our solar system existed. Some exploded and seeded the cloud that eventually became our world. We are latecomers inside a structure with immense seniority. Gravity has been writing its quiet laws across this galaxy for billions of years. Our ambitions are new. The system that holds us is old. There is something oddly soothing in that too. Not comforting exactly, but clarifying. We are not dealing with a problem of bad luck or poor timing. We are dealing with one of the basic arrangements of reality. The galaxy holds what belongs to it because that is what mass does. Not maliciously, not dramatically, just faithfully. And yet human beings are human beings. We still imagine overcoming it. We still imagine that somewhere ahead lies the engine, the method, the breakthrough that can turn all this pull into a challenge rather than a prison. That instinct is part of what makes us who we are. We look at barriers and immediately begin translating them into future problems to solve. But there is a difference between a hard problem and a gentle trap. Distance is a hard problem. Speed is a hard problem. Gravity is something quieter. It means the longer journey is not just long, it is uphill. If this slow passage through the galaxy is helping you relax, you can quietly leave a like, subscribe, or share where you're listening from tonight. It is always a little surreal to imagine this thought traveling through phones and speakers on one small planet while the whole solar system continues its silent orbit around the Milky Way. So now the shape of the problem is becoming clearer. Part 2 showed us how large the Milky Way is. Part 3 showed us where we are inside it. Part 4 revealed that speed, even astonishing speed, struggles to make those distances manageable. And now Part 5 adds the next layer. The galaxy is not just a large place to cross. It is a gravitational system to escape. Home is not sitting still while you depart. It is pulling on you, continuously, with a force written into the mass of the stars, gas, dust, and unseen matter around you. That means leaving is never just about motion. It is about liberation. And liberation, in a galaxy, is much harder than it first sounds. Because in the next part, we have to face the most unsettling twist of all. The Milky Way's gravity does not end where its light begins to fade. In some ways, that is where the real Milky Way is only beginning. Part 6, the invisible halo around the galaxy. If the story ended with the stars, the Milky Way would already be difficult enough to leave. That alone would be more than enough to trouble the imagination. A galaxy 100,000 light-years across. Hundreds of billions of stars. Vast distances. Quiet gravitational discipline. A home large enough to humble any species that dares to measure it honestly. But the story does not end with the stars. And that is where it becomes even stranger. Because there is something very human about trusting what we can see. It is not a flaw exactly. It is simply how life begins. We learn the world through surfaces first. Through light. Through shape. Through edges. We understand a forest by the trees we can count. We understand a coastline by the line where land meets water. We understand a city by its skyline. And when we look at the Milky Way, glowing softly across the night, some quiet part of the mind wants to do the same thing. It wants to believe the galaxy ends where the light thins out. But the universe is under no obligation to make itself so tidy. The visible Milky Way, beautiful as it is not the whole Milky Way. It is only the part that shines brightly enough for our eyes and telescopes to notice first. Like a lantern seen from far away, it marks a presence. But it does not reveal the full size of what surrounds it. In a way, the visible galaxy is the warm center of a much larger, colder domain. And that larger domain is where the idea of escape becomes far more unsettling. Imagine standing at night on the edge of a great plain. In the distance, you see the lights of a town. Roads, windows, maybe the faint hum of life. From where you stand, it is natural to assume the town ends where the lights stop. Beyond that must be open land, freedom, emptiness. But what if the town is only the visible heart of something much larger? What if beyond the lit streets lies a vast territory still under its control, though no lamps mark the boundary? What if the power lines, the laws, the reach of that place extend far into the darkness, long after the familiar glow has vanished? That is closer to the truth of the Milky Way. The stars form the bright inner impression. The disk, the spiral arms, the central bulge, the luminous clouds of gas and dust, these are the parts we fall in love with first. These are the parts that seem to define the galaxy. But surrounding all of that is something larger, dimmer, and more mysterious. A vast halo. Not a glowing shell. Not a neat border. more like an immense, invisible sphere of influence extending far beyond the bright disk. And for a long time, humanity had no real idea it was there. This is one of the beautiful things about astronomy. Again and again, it teaches us that the most important parts of a system are not always the parts we notice first. We once thought the stars themselves were the whole of the sky. Then we learned about nebulae, galaxies, black holes, cosmic background radiation, invisible wavelengths, hidden structure. The deeper we look, the more the universe seems to say, gently but firmly, there is more here than you imagined. The invisible halo around the Milky Way belongs to that tradition of surprise. To understand how we found it, it helps to step away from the image of the galaxy for a moment and think only about motion. Because motion, when studied carefully, has a way of revealing what the eye cannot see. Think of children on a merry-go-round. The farther from the center they sit, the harder they feel themselves being pulled outward. If the ride spins too fast, those at the edge would be the first to lose their grip. Now imagine something similar on a cosmic scale. Stars orbiting the center of a galaxy. Those near the middle might be expected to move quickly, since much of the mass is concentrated there. Those far out at the edges, where the visible matter becomes thinner, should move more slowly. That is what simple intuition suggests. And yet, when astronomers measured how fast stars and gas clouds were moving in the outer parts of galaxies, including our own, they found something unexpected. The outer regions were moving too fast. Too fast for the amount of visible matter we could account for. If the galaxy consisted only of the stars, gas, and dust we could see, then many of those outer stars should not remain in their orbits. They should drift away. The visible Milky Way did not seem heavy enough to hold itself together in the way it actually behaved, and so a strange conclusion emerged. There had to be more mass. A lot more. Not a little extra dust here and there. Not a few missed stars. Something enormous. Something widespread. Something that did not shine. This is where dark matter enters the story. Now, dark matter is one of those phrases that can become more intimidating than it needs to be. It sounds dramatic, almost mythic, like something lurking in the shadows. But for our purposes, it is enough to think of it simply as unseen mass. We do not know exactly what it is made of. We cannot hold it in our hands. It does not emit light the way stars do, and it does not interact with ordinary matter in the familiar ways that make things visible. But it has gravity. And gravity leaves fingerprints. The stars in the Milky Way move as though they are embedded in a much larger mass than the visible galaxy alone can explain. So astronomers began to understand the Milky Way not as a bright disk floating alone in empty space, but as a smaller luminous structure sitting inside a far larger halo of dark matter. And once that idea settled in, the scale of home changed instantly. The visible disk of the Milky Way is roughly 100,000 light-years across. Already enormous. Already enough to silence human scale. But the dark matter halo that surrounds it is thought to extend much farther. Estimates vary, and astronomy is careful where certainty is incomplete, but the halo may stretch out to nearly 1 million light-years from the galactic center, perhaps even more depending on how one defines its outer limits. In other words, the true gravitational territory of the Milky Way may span something closer to 2 million light-years across. 2 million. That number changes the emotional geometry of the whole subject. Because suddenly, leaving the stellar disk no longer sounds like leaving the galaxy. It sounds like stepping out of the brightly lit front room and discovering that the house extends through darkness farther than you ever imagined. The visible Milky Way becomes not the whole structure, but the glowing core of something much larger and harder to escape. This is why Part 1 used that phrase, the first great deception. When you picture a starship rising above the plane of the galaxy, watching the familiar band of stars shrink into a distant spiral, it feels like success. It feels like the moment of departure. The last bright stars fall behind. The disk is beneath you. The Milky Way becomes an object instead of an environment. Surely, that must mean you have left. But not really. Not in the deepest sense. Because the real boundary is not where the starlight fades. The real boundary is where the galaxy's gravitational influence finally loosens enough for escape to be meaningful. And that boundary lies much farther out, inside a realm where the eye sees very little. That is what makes the halo feel so haunting. It is not just large. It is silent. If you were traveling outward, there would be no bright sign telling you that you had entered it. No wall. No sudden visual change. No dramatic threshold. The last dense stars of the disk might fall away behind you. The sky would darken. Familiar galactic scenery would thin into remoteness. And yet you would still be deep inside the Milky Way's larger hold. There is something almost dreamlike about that. To travel through darkness and still not be free. This is part of why astronomy can feel so psychologically powerful when it is allowed to breathe. It reveals traps that do not look like traps. Structures that do not announce themselves. Distances with no markers. We are used to boundaries that show up clearly. A doorframe. A border. A shoreline. The halo does not behave that way. It is a boundary made of influence, not appearance. And because of that, it changes the meaning of the phrase, one-way trip. If leaving the galaxy meant only clearing the visible disk, then the problem would already be severe. But if leaving truly means escaping the full halo, then the journey becomes even longer, even stranger, and much more final than the eye would ever suspect. It also means that what we call the Milky Way depends a little on what question we are asking. If we are asking what the galaxy looks like in photographs, then the visible disk dominates the answer. The spiral arms, the central bulge, the dark dust lanes, the luminous star clouds, those form the familiar face of home. But if we are asking what the Milky Way is as a gravitational system, then the answer extends much farther. Now the galaxy includes its globular clusters scattered far above and below the disk, its diffuse gas, its faint outer stars, and above all the dark matter halo that surrounds everything else like an unseen kingdom. So the galaxy has two scales, in a sense. There is the scale of what shines, and there is the scale of what rules. Those are not the same. This is not unique to the Milky Way, of course. Other galaxies appear to have similar halos. The universe is full of structures whose visible beauty is only the center of a deeper invisible arrangement. But it feels different when the galaxy in question is your own. When it is the structure that contains your sun, your planet, your history, and every human life that has ever unfolded. Then the halo is no longer just an astronomical concept. It is part of the answer to a very intimate question. How far inside home are we, really? The answer is, deeper than we once thought, and perhaps more deeply than the human mind is naturally prepared to feel. There is also another quiet consequence to the halo. It helps explain why the Milky Way is not alone in a simple, isolated sense. Galaxies are embedded in larger gravitational contexts too. The Milky Way and Andromeda, for example, are both part of the local group, a small gathering of galaxies bound together over cosmic time. Their halos may even influence one another at the edges in subtle ways. Space between galaxies is not always the clean emptiness our imagination prefers. There are gradients, influences, overlapping histories, invisible structure. That thought can be strangely calming. The universe is not a collection of disconnected islands floating in nothing. It is more relational than that. Things extend. Fields overlap. Motion remembers mass. Even in the darkness, structure persists. Still, for someone trying to leave, that is not exactly comforting. Because the halo means the Milky Way does not release you simply because the scenery changes. It means the journey outward remains uphill long after the visible landmarks are gone. It means that the ship, no matter how advanced, is not just moving across distance. It is crossing a hidden depth. And hidden depth is always more tiring than visible distance. Imagine walking into fog. At first, the path seems short because you cannot see how much remains. You move forward assuming the world beyond the mist will appear soon enough. But the farther you go, the more you realize that the fog is not a passing veil. It is the environment. It continues long after you expected it to end. That is a little like the halo. The visible stars are the clear landscape. The halo is the continuation you do not see coming. This is why the question of leaving the Milky Way needs such careful wording. People often say things like, "What if humanity one day reaches intergalactic space?" It sounds straightforward, but what counts as reaching it? Leaving the solar system is one thing. Leaving the visible disk is another. Leaving the outer stellar halo is yet another. Escaping the dark matter halo entirely, that is something deeper, something harder, something much closer to what truly leaving would actually mean. And once those definitions become clear, the dream becomes much more lonely. Because there would be no applause when you crossed the real threshold. No ceremony. No moment where the universe confirms that you have done it. You would simply continue outward for ages, through ever sparser darkness, until eventually the mathematics of your motion change. Until eventually the Milky Way no longer owned your future path. The greatest act of departure in human history would happen not in a dramatic instant, but in silence, somewhere far beyond the place where any human eye would have guessed the boundary lay. There is something almost sad in that. We like milestones. We like visible endings. We like knowing when something has happened. But the halo denies us that comfort. It says the truth of a system is not always where the light is. It says leaving home is more complicated than watching the lights go dim. And in a sense, that is true even in ordinary life. Sometimes the visible signs of leaving come first. A move, a goodbye, a train station, a new room in a new city. But the deeper leaving, the emotional one, happens later and less clearly. There is no single moment when you know you are truly no longer part of what once held you. Perhaps that is one reason this galactic idea feels so familiar in the bones. The Milky Way's halo is a cosmic version of that hidden continuation. You think the departure happened already. But the deeper bond is still there. Of course, unlike human memory or belonging, gravity is not sentimental. The halo does not keep you because it loves you. It keeps you because mass curves motion, because that is what the universe does. But the emotional resonance remains. Home extends farther than it first appears. Astronomers are still learning the details of the Milky Way's halo. The exact distribution of dark matter, the way smaller galaxies and streams of stars move through it, the precise outer structure, all of this remains an active field of study. And that too is part of the beauty. We do not yet have a final map of the invisible. We are still inferring, still measuring, still listening to gravity's quiet testimony. There is humility in that. Even now, inside our own galaxy, there are dimensions of home we are still trying to understand. And if understanding it from here is already difficult, escaping it becomes something else entirely. A ship leaving Earth would first have to escape Earth's gravity. Then the sun's. Then, over immense time and distance, the Milky Way's visible structure. And beyond even that, the dark halo. Each layer sounds manageable when spoken quickly. But layered together, they form a staircase of difficulty so high that ordinary imagination starts to lose its grip. That is the invisible halo's real contribution to this story. It does not merely add more distance. It adds another layer of hidden captivity. It tells us that the galaxy is not what it looks like from the inside. That home is bigger than the lights. That departure is deeper than sight. And that if one day humanity ever does try to leave, the hardest part may begin only after the familiar beauty of the stars has already fallen behind. If this slow passage through the deeper shape of the Milky Way is helping you relax, you can quietly leave a like, subscribe, or share where you're listening from tonight. There is something quietly beautiful in that image too, voices and minds gathered on one small world, speaking softly about the invisible structure surrounding us. So now the Milky Way has changed again in our minds. It is no longer just the glowing band across the night. It is no longer even just the vast disk of stars and dust. It is a layered structure, a luminous interior held inside a much larger invisible halo, a galaxy whose true reach extends far beyond what the eye would ever call its edge. And that leaves us with a question that matters more than ever now. When people say, "Leave the Milky Way," what do they actually mean? Do they mean leaving the solar system? Leaving the region of familiar stars? Leaving the visible disk? Leaving the halo? Or truly escaping everything that still counts as home? That is the distinction we need next. Because before we can understand why the trip becomes one way, we have to decide what leaving really is. Part 7. What leaving actually means. By this point, the phrase itself has started to feel less innocent. Leave the Milky Way. At first, it sounds simple, almost childlike in its clarity. As if the galaxy were a house, or an island, or perhaps a country with a visible border, and all you would need to do is keep moving until you crossed it. The mind loves clean verbs. Leave, escape, arrive, return. These words make difficult things feel organized. They make the universe sound as though it shares our preference for doors and thresholds. But it does not. And so before we go any farther, we have to pause over the phrase itself and ask a question that turns out to matter more than most people expect. What does it actually mean to leave the Milky Way? Not poetically, not emotionally, not in the way a headline might use the phrase, or the way a dream might imagine it, but physically, structurally, in the language of real space, real distance, and real gravitational systems. What counts as leaving? Because once you begin answering that honestly, the whole idea starts to separate into layers. And each layer reveals that what most people picture as departure is not really departure at all. It is only one kind of distance from home, sometimes not even the deepest kind. This happens often in science. A word seems obvious until we ask it to become precise. Then suddenly it opens into complexity. We think we know what it means to touch a star, to reach the edge of space, to see the universe, to leave a galaxy. But nature rarely honors the first version of our language. It asks for definitions. It asks what exactly you mean. And the Milky Way is one of those places where definition changes everything. For example, one person might say leaving the Milky Way means leaving Earth. Another might say it means leaving the solar system. A third might imagine the moment when the bright band of our galaxy no longer dominates the sky. Someone else might mean crossing beyond the visible disk of stars. And an astronomer, thinking more carefully about gravity, may say none of those things are enough. Not if the galaxy's true reach continues much farther through its dark halo. So which one is right? In a certain sense, all of them are describing a departure. But they are not describing the same departure. And that difference matters because the emotional shape of the journey changes depending on which threshold you have in mind. Leaving Earth is dramatic to us because Earth is the cradle of everything human. All language, history, music, memory, grief, invention, all of it began here. To leave Earth is already a profound act. It means severing yourself from weather, from oceans, from a breathable sky, from the ordinary softness of gravity and the familiar cycle of day and night. In emotional terms, leaving Earth feels enormous. It is the first true exile most of us can imagine. But of course, leaving Earth is not leaving the Milky Way. Not even close. The Moon is still Earth's companion. Mars is still nearby in a cosmic sense. The planets all belong to one small family around one ordinary star. If a ship left Earth tomorrow, no matter how far it went within the solar system, it would still be moving inside the local household of the Sun. So perhaps leaving the Milky Way means leaving the solar system. That feels more serious. Now we are no longer talking about planets and moons. We are talking about going beyond the influence of the Sun, beyond the protective bubble of the heliosphere, beyond the region where our star is the clear center of everything. This is the boundary Voyager 1 crossed when it entered interstellar space. That phrase, interstellar space, has a certain chill to it. It sounds lonely, and rightly so. It means the environment between stars. The local emptiness beyond our solar neighborhood. A vast region where the sun is no longer the dominant weathermaker of charged particles. And yet even that is still nowhere near leaving the Milky Way. Because interstellar space is not intergalactic space. It is still local. Still inside the galaxy. Still within one small district of the larger structure. If the Milky Way were an entire continent, leaving the solar system would be like walking out of one house and into the open countryside. Important, certainly. Transformative, maybe. But still inside the same land. Then maybe leaving the Milky Way means leaving our stellar neighborhood. That too sounds plausible at first. Perhaps once the sun becomes just another faint star among many. Perhaps once the nearest constellations lose their familiar shapes. Perhaps once the local pattern of stars rearranges itself completely. Maybe then you have truly departed. Home, after all, is often what looks familiar. Once the sky no longer resembles the sky of Earth, doesn't that count as having left in some meaningful way? Emotionally, perhaps it does. But physically, not yet. The sun may fade behind you. Nearby stars may become only points among other points. Even whole constellations may dissolve into strange new geometries. But that is still only a change in perspective inside the galaxy. It is not escape from the galaxy itself. It is relocation within the same larger system. This is one of the strange things about cosmic scale. You can travel far enough to lose all visual familiarity and still not have left in the deeper sense. The scenery changes long before the structure does. Then perhaps leaving the Milky Way means leaving the visible disk. This is the version many people carry in their minds without realizing it. They picture the galaxy as that great luminous spiral, or as the glowing band across the night sky. So naturally, they assume that once you rise above the disk, or pass beyond the last significant stars in the galactic plane, that is the threshold. The bright city of stars is behind you. The Milky Way is now an object rather than an environment. Surely that must count. It certainly looks like it would. If a traveler could rise far enough above the galactic plane, the Milky Way would transform from a sky-filling river of light into a grand spiral seen from outside. The visual drama of that moment would be almost impossible to overstate. For the first time, home would not be all around you. It would be below you. The galaxy would be visible as a structure, not merely inhabited as a place. And yet this too is deceptive. Because as Part 6 made clear, the visible disk is not the full extent of the Milky Way. It is only the luminous center of a much larger gravitational territory. The stars are what make the galaxy beautiful to the eye, but not what defines its full reach. Beyond the bright disk lies the outer stellar halo, globular clusters, diffuse gas, and farther still, the dark matter halo, vast and mostly invisible, extending much deeper into the surrounding darkness than the eye would ever guess. So if a ship merely leaves the bright disk, it has not necessarily left the Milky Way. It has only left the part of the Milky Way that glows most obviously. That is not a trivial distinction. It means what looks like departure may only be an exit from the front room. And this is where the phrase leaving the galaxy becomes truly delicate. Because now we are forced to distinguish between visible departure and dynamical departure. Between looking outside the galaxy and actually no longer belonging to it. One is an optical change. The other is a physical one. The first concerns what you see. The second concerns what still owns your path. This is why astronomers and physicists often care less about whether something has traveled beyond the stellar disk and more about whether it remains gravitationally bound. As long as an object is still bound to the Milky Way, still destined by its velocity and trajectory to remain part of the system, then in the deepest sense it has not left. It may be far away. It may be in darkness. It may even feel free. but gravity still includes it in the larger story. That is the real distinction. You can be far from home and still belong to it. That sentence sounds emotional, but in this case it is simply physics. True leaving, in the strictest sense, means escaping the full gravitational influence of the Milky Way strongly enough that you are no longer bound to it. Not just beyond the visible stars. Not just beyond the pretty part. Beyond the point where the galaxy's pull still determines your long future. Beyond the dark halo. Beyond the hidden continuation of home. Only then, really, do you begin to deserve the phrase, "You have left the Milky Way." But now notice what this does to the whole emotional structure of the journey. It means that departure is not a single event. It is layered. Leaving Earth is one kind of leaving. Leaving the solar system is another. Leaving the local stars is another. Leaving the visible disk is another. Leaving the galaxy in the full gravitational sense is another still. And each of these departures strips away a deeper level of familiarity. First you lose your planet, then your star, then your neighborhood, then the luminous architecture of home, then the invisible force that still claimed you. This layering matters because it tells us something profound about how humans misunderstand scale. We often think in pictures first. If the galaxy looks small behind us, we assume we have left it. But in reality, structure does not end where appearances do. A place can remain physically meaningful long after it has stopped looking central. That is true in life as well, in quieter ways. A person may leave a hometown and still be shaped by it for decades. A family may no longer live together and still carry one another in invisible ways. The visible part of belonging ends first. The deeper part lingers. The Milky Way's halo is a cosmic version of that same truth. Home extends beyond what is easy to see. And because of that, the greatest confusion in this entire subject may simply be one of naming. When science fiction says a ship has left the galaxy, what does it mean? Has it gone beyond the stars we can easily see? Has it entered a sparse outer region? Has it escaped the dark matter halo? Has it entered true intergalactic space in a way that guarantees it will never fall back? Often the phrase is used as though these are all the same thing, but they are not. And the difference between them can be hundreds of thousands, even millions, of light years. That is the part the imagination resists most strongly. Because the human mind wants milestones. It wants a clear gate. A moment you can point to and say, there. That is where the old world ended. That is where the new one began. But cosmic thresholds are rarely so generous. Sometimes they are visual. Sometimes they are mathematical. Sometimes they are only obvious in hindsight. A ship may appear to have left long before it really has. Or it may truly escape at a moment no one inside it can perceive as special at all. There is something beautiful and a little tragic in that. Imagine the greatest journey ever undertaken by a civilization. A departure from the Milky Way itself. And yet there may be no single window view moment when everyone gasps and says, "This is it." Instead, home might simply thin and thin and thin, until one day, according to the cold arithmetic of gravity, the galaxy no longer owns your future. The most decisive threshold in human history could happen in silence, without ceremony, somewhere in the dark where almost nothing looks different. This is why the question of meaning matters more than the question of imagery. What counts as leaving depends on what kind of truth you care about. If you care about emotional departure, then leaving Earth already qualifies. If you care about leaving your star behind, then crossing into interstellar space may feel sufficient. If you care about visual departure, then perhaps leaving the galactic disk is enough. But if you care about the actual physical release from the Milky Way as a gravitational system, then none of those earlier milestones are the real answer. Only escape is. And even that word, escape, deserves gentleness here. It sounds dramatic, but the reality is quieter. Escape does not mean victory in some cinematic sense. It simply means that if you stopped trying, if your engines went silent, if you surrendered to the laws of motion entirely, the galaxy would no longer pull you back into belonging. Your path would remain your own, at least with respect to the Milky Way. That is a colder definition of freedom than most people expect. Not emotional freedom, not visual freedom, gravitational freedom. And perhaps that is why this whole topic feels so haunting. It reveals that many of the milestones our imagination celebrates are not the milestones physics cares about. You can leave Earth and still belong to the Sun. You can leave the Sun and still belong to the galaxy. You can leave the bright galaxy and still belong to the halo. Again and again, the boundary moves farther outward than the eye first believes. There is another layer to this too, one that makes the phrase one-way trip feel even heavier. Because once you start defining leaving carefully, you realize that returning is not a simple reversal. If you merely left Earth, in principle you might come back to Earth. If you merely left the solar system, perhaps with enough time and power, you might come back to the Sun. If you merely left the visible disk, perhaps you are still within reach of the galaxy's larger embrace. But once you truly leave in the deepest sense, once you are no longer bound, return becomes a different kind of problem entirely. Now you are no longer making an excursion from home. You are becoming external to it, a true outsider. Your future path belongs to a wider darkness. And that changes the psychological tone of everything. An expedition suggests eventual return. An escape suggests something else. That is why this part of the story matters so much. Before we can understand why leaving becomes one way, we have to agree on what leaving really means. Otherwise we end up talking past the real problem. We imagine a ship cruising beyond the bright stars and call it gone, when physics would still call it local. We imagine exile beginning early, when in fact the deeper release may not yet have happened. Or worse, we imagine the possibility of coming back because we have mistaken one layer of departure for the final one. The Milky Way does not make things that easy. It offers many levels of distance before it offers true freedom. And maybe that is part of what makes our own position inside it feel so intimate. We are not just in a galaxy. We are nested inside it, layer by layer. Planet inside solar system. Solar system inside local stellar neighborhood. Neighborhood inside spiral structure. Spiral structure inside galactic disk. Disk inside halo. Halo inside the larger company of nearby galaxies. The universe is not a flat place. It is an arrangement of containments. Leaving one layer does not mean leaving them all. That may be one of the deepest lessons in astronomy. A smaller truth can feel like the whole truth until a larger scale reveals itself. Earth felt central until we noticed the Sun. The Sun felt central until we noticed the galaxy. The galaxy itself begins to feel less solitary once we notice the local group and the cosmic web beyond it. Again and again, what seemed like the whole turns out to be only the inside of something larger. And here, in Part 7, we are standing inside one of those transitions. We are learning that leaving the Milky Way is not one event but several possible thresholds, layered from the obvious to the invisible. And only the deepest threshold, the one that frees you from the galaxy's gravitational claim altogether, really deserves the name in full. Once you understand that, the next part becomes almost inevitable. Because now the question is no longer what leaving means. Now the question is what that leaving costs. Not just in distance, not just in speed, but in time, in return, in memory, and in the practical fading of home itself. Because once you truly begin to leave the Milky Way in the deepest sense, coming back stops being a romantic idea. It starts becoming something much harder. Something that, for all practical purposes, begins to look impossible. Part 8, Why Return Becomes Almost Impossible. Once you begin to define leaving carefully, another question rises almost on its own. Could you come back? At first, the answer seems like it should be yes. Difficult, perhaps. Expensive, certainly. But not impossible in principle. After all, in ordinary life, most journeys are reversible. If you can go somewhere, you can usually come back from it. A road that leads outward also leads inward. A ship that crosses an ocean can turn around. Even a spacecraft, in the smaller scales we are used to, can often treat motion as something symmetrical. Outbound and inbound. Departure and return. One path there, another path home. It is one of the quiet assumptions our minds carry into space. And it is one of the first assumptions the galaxy breaks. Because the farther outward you stretch this dream, the more return begins to change in character. It stops being the second half of a journey and becomes a second impossible journey layered on top of the first. Then, beyond that, it becomes something even sadder. Not merely hard to do, but hard to mean, hard to define, hard to hold onto as the same idea once time, energy, distance, and the slow alteration of everything familiar begin to do their work. This is where the phrase one-way trip stops sounding dramatic and starts sounding precise. Not because some law of nature literally forbids the concept of turning around, but because once you follow the logic all the way through, return becomes so difficult, so wasteful, so delayed, and so disconnected from the thing you wanted to return to, that the word itself begins to lose its ordinary meaning. And that loss begins sooner than most people think. Imagine the first stage of departure. A ship leaves Earth. Already, coming back is no small thing. It must preserve life, preserve structure, preserve guidance, preserve intention. Even a trip to another planet tests that. Radiation, isolation, machinery, fuel, communication delays, closed environments, all of these become problems before the galaxy even enters the conversation. Space travel is never simply motion. It is survival while moving. Now extend that to the solar system, then to interstellar space, then to the outskirts of the Milky Way. At each layer, the return trip does not merely add distance. It multiplies burden, because every outward kilometer creates an inward obligation later. Every gram of fuel you use must be accounted for in a system that must also remain alive long enough to need that fuel. Every failure that accumulates on the way out follows you into the way back. Every year of absence becomes a year in which home changes without you. That is the first quiet reason return becomes almost impossible. A journey outward can be fueled by hope. A return journey must be fueled by preservation. And preservation is much harder. It helps to think about ordinary expeditions. A mountaineer climbing higher must still save enough strength to descend. A diver going deeper must still budget enough air to come back. In dangerous environments, the return is often the true test. The summit is emotional. The descent is practical. Many journeys are won not by reaching the far point, but by getting everyone safely home again. Space magnifies that truth to an almost merciless degree. Because there is no air to breathe along the way, no water to gather, no shelter to improvise from the environment, no village beyond the mountain pass, no harbor over the next horizon. A starship leaving the Milky Way, or even truly trying to, would not be like a sailor crossing seas. It would be more like a tiny sealed world carrying all of its own fragility into a darkness that offers almost nothing in return. And that means every thought of coming back begins with a frighteningly simple question. What, exactly, will you still have left by then? Will the ship still function? Will the engines still be trustworthy? Will the habitat still hold pressure? Will the life support still run? Will the people still know why they are returning? Will there even still be the same people? On human timescales, we often imagine return as a continuation of intention. You leave in order to come back. The decision to return belongs to the same life that made the decision to depart. But on galactic scales, that continuity starts to break apart. If a journey takes centuries, then the people who return may not be the people who left. If it takes millennia, then return becomes a mission inherited by descendants. If it takes tens of thousands of years, then even culture itself begins to loosen. Language changes. Memory fragments. Ritual replaces direct knowledge. Motive has to be preserved artificially. The original Earth becomes an idea more than a destination. That is not ordinary return anymore. That is archaeology in motion. And even this assumes that a civilization aboard such a ship remains stable enough to preserve the desire to come back. That alone is not something to take lightly. Human beings do not merely survive through systems. They survive through meaning. They need story, continuity, social trust, shared purpose. The longer a journey becomes, the more fragile that shared purpose can become. Imagine being born aboard a vessel between stars, or worse, beyond the familiar regions of the galaxy. Your ancestors left long ago for reasons so old they already feel mythic. Earth, to you, is not home. It is ancestry. The sun is not the star of your childhood sky. It is a historical object, a remembered light transmitted through education and ritual. The Milky Way itself, once a lived environment, may have become an abstract map in the minds of those born deep into the voyage. Now tell that person it is time to go back. Back where? Back to what? Back to a place they have never seen? Back to a world that may no longer exist in any recognizable form? That is the second reason return becomes almost impossible. Not because propulsion fails, but because belonging changes. The farther you go, and the longer you are gone, the more the return destination starts dissolving as an emotional reality. Home is no longer where you are from. It becomes where your ancestors were from. Then eventually it becomes where a story began. And stories are powerful, but they do not always command engines. This is one reason the one-way quality of the journey is not only physical. It is cultural, psychological, even spiritual, in a quiet secular sense. Some distances do not merely separate places. They separate identities. Once you have lived too long away from a place, returning to it is not always the same as going home. Sometimes it is only arriving at the location where home used to be. And in the case of the Milky Way, that problem becomes enormous. Because the galaxy is not static while you travel. The sun keeps moving around the galactic center. Nearby stars drift. Constellations deform. Clouds of gas shift. Small galaxies tug and merge. Time is not waiting for you. So even before we get to the larger cosmic effects waiting in later parts of this story, the simple fact is that the Milky Way you return to would not be the Milky Way you left. The familiar sky of Earth would not be preserved for your convenience. This is something people rarely feel deeply enough. We speak about the sky as though it is a fixed backdrop, but it is not. It is a temporary arrangement seen from one temporary point. Over thousands, millions, and billions of years, its patterns change. Stars move. Some die. Others are born. The whole galaxy turns. So a ship that departed with a memory of a certain home sky would not return to the same celestial arrangement. Even if Earth survived, even if humanity survived, even if the sun still shone calmly, the emotional geometry of the sky itself would be altered. Return would not restore what was lost. It would only bring you to the place where change continued without you. There is another practical cruelty hidden in the return problem too. Fuel. Or more broadly, energy. Any trip outward already demands enormous energy. A trip outward and back demands much more. Not merely twice as much in a naive sense, because any fuel you carry adds mass, and extra mass demands extra energy to accelerate, decelerate, preserve, and control. This is one of the oldest and harshest truths of rocketry. The more fuel you need, the more fuel you need just to carry that fuel. It becomes a kind of recursive burden. On short missions, this is difficult. On interplanetary missions, it becomes severe. On interstellar or galactic scales, it becomes almost absurd. A ship intending to leave the Milky Way and return would need not only the energy to climb away from all the gravitational layers we have already discussed, but also enough remaining capacity to reverse that motion later, to aim again with astonishing precision, and to sustain a living system across the entire cycle. It is not impossible to write those words. But once you let them become physical, Once you imagine actual mass, actual structure, actual failure points, actual maintenance over immense spans of time, the idea starts to feel less like an expedition and more like an act of impossible stubbornness. And that is before considering wear. Machines age. Materials fatigue. Even in carefully controlled environments, seals degrade, radiation accumulates damage, moving parts fail, software drifts into obsolescence, micrometeoroid impacts take their quiet toll, and small errors compound. We already struggled to keep machines operating flawlessly for decades under comparatively favorable conditions. A ship surviving not just the outward voyage but also a meaningful return, across deep galactic timescales, would need to be something more than a machine. It would need to be a civilization of repair, a culture of maintenance, a society built not only to travel, but to endlessly preserve the possibility of turning around. That is a very different dream from adventure. Adventure imagines the far horizon. Return requires discipline so severe it begins to sound monastic. And perhaps that is the moment when the phrase one-way trip starts to feel almost merciful. Because a one-way voyage, for all its sadness, is at least internally honest. It accepts exile. It accepts finality. It accepts that the goal is not to preserve the old world in both directions, but to carry forward something of it into a new and perhaps unreachable future. A round trip, by contrast, asks for a strange kind of denial. It asks the universe to hold still. It asks technology not merely to be powerful, but durable beyond precedent. It asks memory to remain relevant. It asks descendants to honor decisions they did not make. It asks home to remain home long after absence has hollowed out what that word means. There is another, subtler reason return becomes almost impossible, and it has to do with information. When you leave your world by enough distance, communication itself becomes a kind of fading thread. Messages do not travel instantly. Even light takes time. A message sent across 1 light year takes 1 year to arrive. Across 1,000 light years, 1,000 years. Across tens of thousands, the numbers become almost ceremonial. They no longer function as conversation. They become historical dispatches. So imagine trying to coordinate a return. Imagine asking Earth, or whatever still exists in Earth's place, if it is ready for you. Imagine receiving an answer long after the questioner is gone. Imagine trying to plan a reunion with a civilization that may transform dozens of times while your message is still in flight. Communication delay turns return from a navigational problem into a philosophical one. You are no longer participating in the same present. And return without shared present is not really return in the ordinary sense. It is arrival into a future that had no way to wait for you. That may be the most painful layer of the whole story. Because the heart of return, if we are honest, is not geography. It is recognition. Return means the place knows you back. It means that the home you imagined still exists in some meaningful continuity. It means your arrival closes something instead of merely ending somewhere. But if you have traveled long enough, far enough, and deep enough, the continuity breaks. The place does not know you. Or what knows you is so different that the emotional logic of return collapses. You may reach the coordinates, but not the home. In that sense, a true galactic return begins to resemble one of those old stories in which someone leaves for what feels like a short time and comes back to find generations gone, kingdoms dust, language strange, memory gone from the world. It is haunting because it violates one of the deepest human expectations. The expectation that time is shared. Space, on these scales, destroys that expectation gently but completely. And yet, strange as it sounds, there is still a kind of beauty in facing this clearly. Because it reveals something about the Milky Way that prettier descriptions do not. It reveals not just that home is large, but that home and time are entangled. The farther you try to leave, the more you are not merely moving through distance. You are moving through the erosion of common reality. The return path grows harder not only because of speed and gravity, but because your relationship to the world you left is aging while you are still trying to hold on to it. And all of this, remember, is before we even talk about the emptiness waiting outside the galaxy. Before we talk about what it means to actually enter the space between galaxies, where there are no neighboring stars nearby, no dense stellar environment, almost no familiar points of practical refuge. Before we talk about the larger cosmological trap that makes the Milky Way itself recede in a deeper way. Those things are still ahead. Already, just from the logic of distance, fuel, maintenance, culture, communication, and time, the return trip is beginning to collapse under its own weight. This is why the emotional tone changes around Part 8. Until now, leaving the Milky Way may still have sounded like a difficult adventure. A dangerous dream, yes, but still a dream of exploration. Here, quietly, it becomes something else. It becomes an act that severs more than one bond at once. Not just place, but mutual time. Not just geography, but continuity. The outward journey does not simply take you away. It slowly strips away the conditions that would make coming back meaningful. So when people ask whether leaving the Milky Way would be a one-way trip, the honest answer is not merely that it would be hard to come back. It is that return begins to unravel on multiple levels long before any formal boundary tells you it is over. First the physics strains. Then the engineering strains. Then the society strains. Then memory strains. Then meaning strains. And by the time all of those layers have been stretched far enough, the phrase "come home" has become something fragile and almost impossible to define. If this calm journey through the deeper logic of space is helping you unwind, you can quietly leave a like, subscribe, or share where you're listening from tonight. It is always strangely comforting to remember that while we are talking about departures so vast they may never close, all of us are still here together on one small world, under one familiar sky. So now the shape of the one-way trip is becoming clearer. Not because a law appears that says no return is allowed, but because the universe keeps subtracting the conditions that make return realistic. The ship must survive. The energy must remain. The people must still care. The destination must still matter. The world must still recognize them. And the farther outward you go, the less any of those things can be taken for granted. That is why leaving the Milky Way does not feel like a grand commute between 2 points. It feels like exile. And in the next part, the feeling deepens even further. Because once you finally do imagine leaving the galaxy behind, what waits outside is not another busy neighborhood of stars. It is something much quieter. Something colder. Something so empty that the Milky Way itself begins to feel, for the first time, like warmth. Part 9. The empty space between galaxies. There is a moment in almost every journey when the traveler realizes that distance is not the same thing as emptiness. A road can feel long without feeling lonely. An ocean can feel vast and still be alive with weather, currents, birds, ships, islands, and shorelines waiting somewhere beyond the horizon. Even deserts, for all their silence, still belong to Earth. They still live under a blue sky. They still hold wind, stone, heat, memory, and the faint promise that somewhere, beyond the sand, there are towns, rivers, mountains, and people. But the space between galaxies is different. It is not simply far away. It is not simply dark. It is a kind of emptiness so deep that the Milky Way itself, once it begins to recede behind you, starts to feel less like a galaxy and more like the last fire in winter. And that changes the emotional meaning of everything we have been talking about. Until now, the problem of leaving the Milky Way has mostly been defined by layers of difficulty. Distance, speed, gravity, the hidden reach of the dark halo, the dissolving possibility of return. Each of those has made the journey harder, sadder, more one-way than ordinary travel ever becomes. But there was still a subtle comfort hidden inside the idea. The comfort of structure. The comfort of home remaining around you, even if it was difficult to escape. The galaxy, after all, is crowded compared to what comes next. Crowded in the cosmic sense, at least. It has stars, dust, gas clouds, nebulae, clusters, planetary systems, black holes, dead stars and newborn stars, motion, light. Even in its lonelier regions, the Milky Way is still an environment. It still has depth and architecture. It still feels like a place. Intergalactic space does not feel like a place in the same way. It feels like the absence of one. And this is where the one-way quality of the journey becomes colder. Because if somehow, against every difficulty we have already described, you managed to truly leave the Milky Way behind, what you would enter is not another bright region waiting just outside the door. It is not like stepping from one city into the suburbs of the next. It is not even like sailing between islands with stars reflected on the water. It is more like stepping out of a cathedral into an endless frozen plain where there are no roads, no lights, and almost nothing to tell you where you are. We use the phrase, the space between galaxies, so casually sometimes, as if the words explain themselves. But they hide something severe. The nearest major galaxy to the Milky Way is Andromeda, and it lies about 2.5 million light-years away. That number alone is enough to stop most thought in its tracks. Not because it is impossible to say, but because the emotional meaning of 2.5 million light-years is difficult to carry in the mind for more than a few seconds at a time. A million light-years is already larger than most human imagination can comfortably hold. 2.5 million means that even after you truly escape the Milky Way's deeper grip, even after all the effort, all the distance, all the irreversible thinning of home, you are still nowhere near another large galaxy. That is the first thing the empty space between galaxies teaches you. Leaving is not arriving. It is only leaving. And the region in between is not some gentle corridor of travel. It is a vast, sparse gulf with almost none of the reassuring structure that the galaxy trained you to expect. This matters because human beings think in landmarks. We orient by contrast, by pattern, by nearby things. A sailor finds stars overhead and shorelines ahead. A pilot finds instruments and horizons. A hiker finds valleys, ridges, rivers, paths. Even in deep space, inside a galaxy, there are still stars around you. Distances are huge, yes, but there is still a visible environment. A ship leaving the solar system and passing through interstellar space still travels within a field of stars. The night remains punctured by suns. Familiar patterns may distort, but the sky still feels inhabited. Intergalactic space would not offer that same feeling. The stars of the Milky Way would slowly compress behind you into a single distant structure. The local neighborhood would vanish into the larger glow of the receding galaxy. Ahead, unless you were aimed toward another major system, there would be no bright destination dominating the sky. Even Andromeda, from certain distances and perspectives, would remain more like a dim structure of promise than a nearby beacon of rescue. And between them would be mostly darkness. Not absolute nothingness, because nature almost never gives us perfect nothing. Intergalactic space contains thin traces of matter. A few atoms here and there. Diffuse gas, often ionized into a sparse plasma. Stray photons moving through the dark. Cosmic rays. Invisible fields. The faint background afterglow of the universe itself. So in a scientific sense, it is not empty the way a blank page is empty. But in every practical, human sense, it may as well be. The density is so low that ordinary language begins to fail. Inside Earth's atmosphere, even the lightest breath is full of molecules. Inside a room, the air is crowded beyond imagination. Inside the solar system, even the vacuum of space is filled with the influence of the sun. Inside the Milky Way, the darkness between stars still belongs to a larger ecosystem of gas, dust, radiation, and gravitational structure. Between galaxies, all of that thins to an almost unbearable degree. And that means something very simple. There is almost nothing there to help you. No nearby stars to harvest energy from. No planets to stop at. No clouds of dense material to use in any comfortable way. No natural chain of stepping stones. No practical refuge if something breaks. No local civilization is waiting in the dark, at least not in any way one could responsibly assume. The space itself offers no support. It is not a medium of passage so much as a medium of endurance. This is why the emptiness matters so much to the idea of a one-way trip. Because up to this point, one could still imagine a heroic ship solving the earlier problems. It escapes Earth. It escapes the Sun. It escapes the Milky Way. It pays the price in time, in energy, in the thinning of return. But perhaps, still, it reaches a wider road beyond. Intergalactic space tells you there is no road. There is only distance. And the difference between those two things is enormous. A road implies continuity. It suggests infrastructure, or at least a shaped path through a larger world. Even if there are dangers, the road belongs to a system of movement. But the space between galaxies is not shaped for travelers. It is not a route laid down by nature for convenient crossing. It is just what remains when enormous gravitational islands are separated by cosmic expansion and ancient distance. That makes the journey feel less like exploration and more like exposure. You are no longer moving through an environment rich enough to make survival feel interactive. You are carrying everything through a region that gives almost nothing back. There is also a deeper psychological chill hiding here. Inside the Milky Way, no matter how far you go, the galaxy itself still frames your existence. The sky still tells you that you belong to something. Even if home has become distant, it is still recognizable as a great structure around you. There is a certain comfort in that, however faint. You are in exile, perhaps, but still within an intelligible world. In intergalactic space, that comfort begins to fall away. Now the Milky Way is behind you as an object. And if you are heading toward Andromeda, that too is still far ahead as another object. Between them is a region so sparse that the mind no longer feels surrounded by place. Instead, it feels suspended between places. Not inside a world, but between worlds. That kind of in-between carries its own emotional weight. Humans are not especially built for the in-between. We like belonging. We like categories. We like being able to say, I am here. I come from there. I am on the way to somewhere. But intergalactic space stretches the middle so far that the middle becomes the entire lived reality. A person born during such a crossing, if that were ever imaginable, would not experience it as a journey between galaxies. They would experience it as existence itself. The void would not be a passage. It would be the world. That is a strange thought. To be born in the gulf. To inherit not a planet, not a sky, not a star, but a sealed interior drifting through millions of light years of near nothing. And this is one reason the one-way nature of the trip becomes even more final. Once your civilization, your ship, or your descendants adapt psychologically to the void as home, what exactly would returning even mean? Return to structure? Return to the crowded richness of a galaxy? Return to a world of stars after generations of living in the abstract middle? Even if physically possible, the emotional geometry of belonging would already have changed. The gulf remakes the traveler. That is what long emptiness does. It also changes the way we think about danger. Most people, when they imagine danger in space, imagine something dramatic. Explosions, black holes, asteroid collisions, violent things. And certainly those dangers exist. But intergalactic space introduces a quieter danger. Not the danger of constant attack, but the danger of almost total indifference. It is the kind of place where a single failure matters more because there is nothing nearby to soften it, absorb it, answer it, or help you recover from it. If a crucial system fails in a city, there are other systems nearby. If a ship gets into trouble near a coast, rescue may still be possible. If something goes wrong on a planet, there is at least an environment to work with, however harsh. But in the void between galaxies, a failure is not just a problem. It is a final conversation with silence. That is worth sitting with for a moment. The emptiness between galaxies is not merely empty in appearance. It is empty in opportunity. And opportunity, in a deep survival sense, is one of the things that makes a journey two-way. The possibility of repair, the possibility of stopping, the possibility of changing plans, the possibility of replenishment, the possibility of outside help. These things make return feel like something more than hope. Intergalactic space strips most of that away. There is also something scientifically beautiful about it, though. The emptiness is not meaningless. In fact, it teaches us something profound about the universe. It reminds us that matter is not spread evenly. The cosmos is structured more like a vast web, with galaxies gathering along filaments and clusters, separated by larger regions of lower density. The universe is not a uniform soup. It is patterned. Galaxies are the bright knots and rivers in a much larger arrangement, while enormous gulfs yawn between them. So when we talk about the emptiness between galaxies, we are really talking about the low-density regions of a cosmic architecture. That is fascinating in its own right. It means the dark is not random. It belongs to a larger design of gravity and expansion that has been shaping the universe for billions of years. But fascinating does not mean forgiving. For a traveler, the cosmic web is not a comfort unless you are already within reach of one of its bright nodes. To be in the gulf is still to be in the gulf. And the gulf makes the Milky Way feel different in memory. That may be one of the saddest, most beautiful transformations in the whole story. At the beginning of this journey, the Milky Way appeared as a limit, a prison, almost, a vast gravitational structure that made escape feel agonizingly difficult. It was the obstacle, the thing holding you, the thing you wanted to transcend. But once you imagine reaching beyond it, once you imagine the long dark between galaxies opening around you, the galaxy itself changes character in the mind. Now it becomes warmth. Now it becomes density, light, history, relation. Now it becomes the last great inhabited thing you knew. This is often how human desire works. From inside a home, we long for what lies beyond it. But when beyond is finally reached, and beyond turns out to be severe enough, the home we wanted to leave can begin to feel like sanctuary. There is something deeply human in that reversal. The Milky Way, once experienced as confinement, becomes in memory a garden of stars. Its crowded arms, once obstacles to be escaped, become richness. Its gravity, once resented, becomes a sign that you belonged to something with shape and meaning. Its glow, once ordinary, becomes what all the darkness outside now lacks. That does not mean the void is evil, of course. Space does not deal in evil. It deals in scale, density, motion, radiation, emptiness. But the emotional effect remains. Intergalactic space is so sparse that it redefines everything behind you as abundance. And this is where the one-way logic deepens almost beyond argument. Because once you leave the Milky Way and enter the gulf, you are no longer just far from home. You are far from any version of home that the human nervous system was built to understand. You are between great structures in a region that offers almost none of the things that make place feel inhabitable. There is no graceful loop implied by that. No natural return arc. No easy symmetry. The outward journey already demanded extraordinary speed, energy, patience, and sacrifice. The environment waiting outside gives you no reward proportionate to that effort except distance itself. That is perhaps the hardest thing to accept. Sometimes the universe is not waiting to congratulate your ambition. Sometimes the far side of a great struggle is not a richer world. Sometimes it is just a colder one. And still, perhaps, some part of us would go. That is the strange thing. Even knowing all this, some part of the human mind remains moved by the idea. Not because it sounds comfortable, but because it touches something very old in us. The urge to know what lies beyond the last firelight. The urge to test the shape of the dark. The urge to look at the emptiest place and still wonder what it would mean to cross it. That urge is noble in one sense. But the space between galaxies answers it with a kind of solemn honesty. Cross me if you can, it seems to say. But do not mistake me for a road. If this calm passage through the deeper loneliness of the cosmos is helping you unwind, you can quietly leave a like, subscribe, or share where you're listening from tonight. It is always a little beautiful to remember that while we are talking about the emptiest regions in the universe, all of us are still gathered here on one living world, under one sky filled with air, sound, and warmth. So now we have arrived at the deeper emotional truth of the journey. Leaving the Milky Way is not only hard because the galaxy is large. It is not only hard because gravity clings to you. It is not only hard because return slowly unravels. It is also hard because outside the galaxy there is almost nothing waiting to hold you. The space between galaxies is not an inviting frontier. It is a sparse and nearly silent gulf where support disappears, landmarks fade, and even the memory of home begins to change shape under the pressure of distance. And that leaves us with one final image. If you really did leave, and if you really did drift far enough into that darkness, there would come a moment when you turned back and looked, not at Earth, not even at the Sun, but at the whole Milky Way itself. The galaxy as a single object. The entire home of your species, shrinking into the black. That is the last view we need to face. Because that is where the one-way trip becomes impossible to romanticize. Part 10, The Last View of Home. At the end of all this, after the numbers and the distances and the strange quiet logic of gravity, there is one image left. Not an equation, not a spacecraft, not a map, just a view. The last view of home. If you have stayed with this journey all the way here, then the Milky Way no longer feels like a decorative band of light crossing the night. It no longer feels like a vague background to human life. It has become something more complete. A structure. A habitat. A vast rotating home that is harder to leave than the imagination first believes. And because of that, the final image carries a different kind of weight. Imagine that somehow, against every limit we have talked about, a human vessel really does go far enough. Far enough beyond Earth that the planet is no longer visible. Far enough beyond the solar system that the sun becomes one star among others. Far enough beyond our local neighborhood that familiar constellations have dissolved. Far enough beyond the bright disk that the Milky Way begins to gather itself into a shape. Far enough, eventually, that even the hidden halo is behind you in the only sense that matters. And then, at some point in that enormous outward silence, someone turns and looks back. What would they see? At first, perhaps, the galaxy would not look especially small. Even from great distance, the Milky Way is too large to surrender its presence quickly. It would still stretch with a kind of dignified brightness against the dark, a broad spiral of diluted light, its central bulge glowing softly, its arms no longer the river we know from Earth but the faint architecture of an entire stellar civilization seen from outside. The black lanes of dust that once carved darkness through the sky might now appear as subtle shadows laid across the galaxy's body. The whole thing would feel less like scenery and more like memory made visible. And it would be beautiful in a way that hurts. Because for the first time, home would be visible as a single thing. That is one of the strangest ideas in all of astronomy. We live inside the Milky Way. We were born inside it. Every human story has unfolded inside it. Yet from Earth, we cannot step back far enough to see the whole structure directly. We know its form through observation, through measurements, through maps assembled patiently by minds and machines. We understand that it is a barred spiral galaxy, that it has arms and a bulge and a halo, but we do not get to stand outside it and witness the whole of our home at once. A traveler leaving the galaxy would. And perhaps that would be the reward, if reward is even the right word. Not a new world, not a triumphant arrival, but a last impossible sight. The first and final time a human eye, or something descended from human eyes, saw the Milky Way entire. There is something profoundly gentle about that thought. All the chaos of life on Earth, all the wars, songs, births, inventions, losses, arguments, discoveries, mournings, funerals, laughter, rainstorms, classroom lessons, whispered apologies, trains at dusk, children falling asleep, cities waking, oceans moving in moonlight. All of it, every single bit of it, contained inside one spiral island of stars. From far enough away, the galaxy would not show any of that detail. No continents, no countries, no languages, no names, no borders, not even the sun as anything obviously special. And perhaps that is part of the reason the image feels so calming. It gathers the whole human drama into one quiet fact. We came from there. That whole luminous thing, so vast that even light takes 100,000 years to cross its visible width, is the shared home of everyone who has ever existed. Every ancestor, every child, every forgotten life, every person who stood under a night sky and wondered what the Milky Way was. Every person who never had the chance to ask. All of them inside that one structure, turning slowly through the dark. And then, if the journey continued, the view would begin to change. Not quickly. Nothing on this scale changes quickly, at least not from the inside of a single human moment. That is part of what makes cosmic thinking so different from ordinary thought. It asks you to get comfortable with changes that would look almost motionless to a lifetime. But still, given enough time, the galaxy would grow smaller. Not dramatically at first. Just enough that the eye would notice that home now occupies less of the window than it once did. This is where the emotional truth deepens. Because the farther away you drift, the more the Milky Way stops being an environment and starts becoming an object. That sounds simple, but it changes something fundamental. From Earth, home surrounds you without asking permission. The stars overhead, the galactic light in the sky, the whole invisible structure of the Milky Way, all of it forms the background condition of life. You do not have to think about it. You are inside it the way a fish is inside water. But once you step outside and look back, that condition becomes a possession of memory. Home is no longer what you are in. It is what you are away from. That may be the deepest meaning of exile. Not merely being distant, but being outside the thing that once defined your ordinary reality. And as the Milky Way shrinks, that exile becomes harder to deny. The galaxy that once felt impossibly large begins, slowly and almost cruelly, to reveal that even impossible largeness can become small from a still larger frame. The same structure that once felt like a prison of gravity now begins to look fragile, delicate, even. A whirl of light suspended in darkness, surrounded by more dark than any eye can fully believe. That is the reversal hidden at the heart of this whole topic. When we began, the Milky Way was the obstacle. The vast system that made leaving seem absurdly hard. The thing holding you. The thing turning escape into a one-way act. But from outside, it changes. Now it becomes warmth. Now it becomes the nearest thing to belonging. Now it becomes the place whose density, light, and history feel almost impossible to replace. And that says something very human about longing. Sometimes we only understand the softness of home when distance has turned it into a single fading shape. There are other layers to that last view too, quieter scientific ones that add to the sadness. The Milky Way is not still while you watch it. Even from far away, it remains a living structure. Stars continue their slow orbits. New stars are born in clouds of gas. Old stars die. Supernovae flare. Black holes feed. Small satellite galaxies move around it. The whole thing continues without you. That may be the hardest part of leaving any place, cosmic or otherwise. The knowledge that what you left does not freeze in your absence. It goes on. And on cosmic timescales, the going on becomes even more severe. The sun, which from Earth feels so permanent, is only one star with a finite life. Over billions of years it will change, brighten, age, swell. Earth itself will not remain as it is forever. The galaxy will change too. And beyond the Milky Way, the universe itself is expanding. That expansion is subtle on small scales and overwhelming on large ones. It does not tear apart galaxies internally, because gravity holds those structures together. But between galaxies, across the deep gulfs of space, expansion keeps stretching the distances. This means that if you are far enough away, and enough time passes, the Milky Way is not just becoming smaller because you are traveling. It is also becoming more remote because the universe itself is quietly changing the geometry between you and home. That is an extraordinary thing to sit with. Home is not only behind you. Home is receding. Not necessarily like a ship disappearing over a horizon, but like a truth being carried away by the larger behavior of reality. The farther outward you go into the gulf between galaxies, the less the old symmetry of return applies. The universe does not preserve roots for sentiment. It does not keep the old roads open because memory wants them. And so the last view of home is not just visually beautiful. It is morally clarifying. It reveals, in one single image, that leaving the Milky Way was never going to be an adventure in the ordinary sense. It was always going to be a separation, a thinning of shared time, a surrender of reversibility, a journey so large that, beyond a certain point, what you call home remains real but no longer remains reachable in the old human way. That is why the phrase one-way trip feels right in the end, not because the universe is cruel. Not because there is a wall with a sign on it, but because everything we value about return, shared present, practical reach, emotional continuity, recognizable home, begins to erode the farther outward the journey extends. The galaxy grows smaller. The possibility of going back grows thinner. And eventually the word return starts describing something memory wants more than physics can realistically offer. There is a quiet tenderness in accepting that, because once we stop fighting the reality of scale, something else becomes possible. We begin to see the Milky Way differently. Not as a prison we failed to escape, but as a home so vast and full that perhaps we never needed to despise its boundaries in the first place. This is where the story settles into its calmest truth. The Milky Way contains hundreds of billions of stars. Around many of them, there are planets. Around some of those, perhaps oceans, skies, chemistry, weather, maybe even other forms of life. We do not yet know. But the possibility alone is enormous. The galaxy is not a small cage. It is an immense territory, almost beyond comprehension, rich with structure, mystery, and time. If humanity were to spend the whole of its future exploring only this one galaxy, that future would still be almost unimaginably large. There is comfort in that realization. The dream of leaving can make us forget what is already here. It can make home feel insufficient merely because it has edges. But everything meaningful has edges. A life has edges. A day has edges. A coastline, a season, a song, a childhood, a human voice in a dark room, all of these are finite, and none of them are made less beautiful by that. Perhaps the Milky Way is like that too. Vast, but not infinite. Rich, but not everything. Enough, in a very deep sense, even if beyond it lies more. This does not mean curiosity is wrong. The desire to know what lies outside our home galaxy is one of the noblest things about human thought. It means the mind is alive. It means we are capable of wonder beyond survival. That matters. Wonder has always mattered. It is why we named the stars. Why we built telescopes. Why we sent Voyager into the dark with music and greetings from Earth. Why we keep asking questions whose answers may never fit comfortably inside a single lifetime. But curiosity does not always lead to possession. Sometimes it leads to perspective. And perhaps that is what this whole journey has really been about. Not a practical flight plan, not a manual for escape, but a change in perspective. A way of seeing the Milky Way clearly enough that the phrase leaving the galaxy stops being a simple fantasy and becomes an honest confrontation with distance, gravity, time, and belonging. Part 2 asked us to feel the size of the Milky Way. Part 3 located us inside it. Part 4 showed how weak our ordinary idea of speed becomes against such scale. Part 5 reminded us that the galaxy is not just large but gravitationally binding. Part 6 revealed the invisible halo, the hidden extension of home. Part 7 forced us to define what leaving actually means. Part 8 showed why return begins to collapse long before the journey is done. Part 9 opened the cold gulf between galaxies. And now, here in Part 10, all of it gathers into one last image. A human gaze, or a gaze descended from ours, looking back at the whole Milky Way and understanding at last what home really was. Not a town, not a nation, not a planet, not even a star. A galaxy. A whole galaxy. That understanding may be sad, but it is also strangely healing. Because once you feel it, once you really let the scale into your mind, some ordinary anxieties seem to loosen. The world does not become less important. It becomes more precious. Earth becomes not smaller, but dearer. The sky becomes not more distant, but more intimate. The Milky Way becomes not a cold abstraction, but the oldest and largest home story we are actually inside. Maybe that is why cosmic thinking can be so restful when it is held gently enough. It reminds you that your life is small, yes, but not meaningless. Small things can belong to very large things without disappearing. A single heartbeat belongs to a body. A single person belongs to a history. A single world belongs to a galaxy. Scale does not erase tenderness. Sometimes it protects it. And so perhaps the last view of home is not only about loss. Perhaps it is also about gratitude. Gratitude that we were born early enough in the universe to see stars at all. Gratitude that our species learned enough to understand what the Milky Way is. Gratitude that on one small planet, minds arose that could imagine standing outside their own galaxy and looking back. That is already remarkable. Whether or not any human being ever truly makes that journey may matter less than the fact that the universe became conscious enough, through us, to ask the question. And if the honest answer to that question is that leaving the Milky Way is a one-way trip, then maybe that answer does not close anything. Maybe it opens something gentler. A renewed sense of what this place already is. A home not diminished by its limits, but defined by them. A home whose very difficulty of escape teaches us how large and rare it really is. If this quiet passage through the cosmos helped you unwind tonight, you can gently like the channel, subscribe, and share in the comments where you're listening from. It is always comforting to imagine so many people, in different rooms and cities and time zones, gathered under the same galaxy while thinking about how vast it really is. And perhaps that is the final thought to fall asleep with. The Milky Way is not just where we are, it is what we are inside. A great spiral archive of stars, dust, darkness, gravity, time, and memory. A place so large that escaping it becomes almost indistinguishable from losing it. A place so rich that even imagining departure teaches you how much there is to love in staying. And somewhere, if you could ever get far enough away, it would hang behind you in the black, quiet and whole, the last view of everything your species had ever called home. That is why leaving the Milky Way is a one-way trip. Not because the dream is foolish, but because home is larger, deeper, and harder to return to than we ever imagined.